Hello there, and welcome to Science for Sleep, where curiosity slows down just enough to feel comfortable, and science takes its time so you don't have to rush through it. Tonight, we're going to explore a question that sounds simple at first, but becomes stranger the longer you sit with it. How fast are you actually moving right now? Not metaphorically, not in the sense of life moving quickly or days slipping by, but physically, truly, in this exact moment. Because although it might feel like you're sitting still, perhaps lying in bed, maybe resting your head on a pillow or leaning back in a chair, there's a good chance you're moving faster than anything you've ever experienced consciously. Faster than a plane, faster than a bullet, faster even than anything you've ever seen with your own eyes. And yet, you don't feel a thing. Before we ease into that idea, let me ask you something simple, just as a small anchor before we drift too far. Where are you listening from right now? And what time is it in your part of the world? It's a slightly curious question, considering what we're about to talk about. Because while you might answer with a city, a country, maybe even a specific room, the truth is, that location isn't as fixed as it seems. If this little journey turns out to be something you enjoy, something that helps you relax or unwind after a long day, then feel free to give the video a like or subscribe if you'd like to return to this quiet corner again. It helps more than you might think. Now let's begin gently. Imagine for a moment that everything around you simply paused, not slowed down, not faded, just stopped. No sound, no motion, no shifting light, completely still. Would you notice anything unusual? At first, probably not. Stillness is familiar. It's what we expect when we sit down, when we lie still, when we close our eyes. It's what we call rest. But here's where things begin to feel a little strange. Even in that perfectly still moment, you would still be moving. In fact, you are moving right now, even as you read or listen to this, at speeds that are almost difficult to imagine. The reason it doesn't feel that way comes down to something surprisingly simple. Motion, as we experience it, isn't about how fast you're going. It's about whether that speed is changing. If you're sitting in a parked car, everything feels still. If that car begins to accelerate, you feel pushed back into your seat. If it brakes suddenly, you feel pulled forward. That sensation, that awareness of motion, comes from change. But if the car moves smoothly at a constant speed, especially on a long straight road, something interesting happens. After a while, it begins to feel like you're not moving at all. You could close your eyes, and without the hum of the engine or the slight vibration beneath you, you might not even know the car was in motion. That's because your body isn't designed to detect constant speed. It detects changes in speed, acceleration, deceleration, shifts in direction. Without those, motion becomes invisible, and that's exactly what's happening to you right now. The ground beneath you feels solid, unmoving, reliable. But it's not stationary. It's carrying you along on a journey that never stops, not even for a second. Let's start close to home. The Earth, the planet you're sitting on right now, is rotating. It completes one full spin roughly every 24 hours, which is why we experience day and night. But that gentle, familiar cycle hides something quite remarkable. At the equator, the surface of the Earth is moving at about 1,670 kilometers per hour. That's over 460 meters per second. To put that into perspective, that's faster than the speed of sound in air under many conditions, faster than a commercial jet at cruising speed, and yet you don't feel like you're spinning. Why? Because everything around you is spinning with you. The air, the ground, the buildings, the oceans, even the atmosphere extending far above the surface. You and everything you can see are part of the same system, moving together at the same speed. There's no sudden push, no jolt, no change in direction that your body can detect. It's a smooth, continuous motion that has been happening your entire life, and long before that. It's a bit like being on a perfectly smooth carousel that never speeds up or slows down. If you are placed on it gently, without any initial movement, You might not even realize it was turning. Now, depending on where you are on Earth, that speed changes slightly. If you're closer to the poles, the distance you travel in one rotation is smaller, so your speed is lower. Near the equator, it's fastest. Somewhere in between, it adjusts gradually. But no matter where you are part of that rotation. You're being carried along by the Earth's spin, whether you're walking, sitting, or lying completely still. And still, nothing feels unusual. That's because your body has no reference point to compare against. Everything in your immediate environment shares that motion. But the rotation of the Earth is only the beginning. Because while the Earth spins, it's also doing something else at the same time. It's orbiting the Sun. Now, this motion is a little harder to picture because it unfolds over a much larger scale. The Earth completes one full orbit around the Sun every year. That's the cycle we measure as 365 days. But the distance involved is enormous, and to cover that distance in that amount of time requires a very high speed. On average, the Earth travels around the Sun at about 107,000 kilometers per hour. That's nearly 30 kilometers every second. Every second. Which means that in the time it takes you to blink, you've already moved dozens of kilometers through space, and again, you don't feel it. The same principle applies. Everything on Earth, including you, is moving along with the planet. There's no sudden acceleration, no noticeable shift. It's a smooth, continuous path through space. If you could somehow pause the motion of the Earth's orbit while everything else continued, the effect would be immediate and dramatic. But because you are part of that motion, because your entire frame of reference is moving with it, it feels like stillness. This is one of the quiet tricks of the universe. Movement without sensation, speed without awareness. You might think of motion as something dramatic, something you notice, something that pushes against you or carries you forward. But most of the motion you experience is silent, constant, and completely hidden from your senses. And what makes it even more interesting is that these motions are layered. The Earth is spinning, yes, but it's also orbiting the Sun. And the Sun itself is not standing still either. It's moving, carrying the entire solar system with it. So even as you sit quietly, perhaps thinking you are perfectly still, you are participating in multiple overlapping motions at once. You are spinning with the Earth. You are travelling around the Sun, and you are being carried through the galaxy, all at the same time, and none of it feels like motion. Take a moment to notice that. There's something slightly comforting about it, isn't there? The idea that even when you feel like nothing is happening, something is always in motion. That stillness, as we experience it, is not the absence of movement, but simply the absence of change in that movement. If you were to stand up right now and take a few steps, you would feel that motion immediately. Your muscles engage, your balance shifts, your body registers the change. But compared to the speeds we've just mentioned, those steps are incredibly small. A walking pace might be a few kilometers per hour, a gentle jog, perhaps a bit more, and yet those are the movements you feel, not the thousands of kilometers per hour beneath you, not the silent journey through space. It's a reminder that your perception of reality is not a complete picture. It's a filtered version, shaped by what your senses can detect and what your brain considers important. Constant motion fades into the background. Change stands out. And so, as you settle a little deeper into wherever you are right now, whether you're listening with your eyes open or closed, you can carry that thought with you. You are not still. You have never been still. Not for a single moment. Even in the quietest, most peaceful pause, you are moving in ways that are vast, continuous, and entirely unnoticed. And as we continue, we'll begin to unfold just how many layers of motion are stacked beneath that simple feeling of rest. At first glance, stillness feels obvious. You sit down, you stop walking, you rest your head, and everything seems to settle into place. The room holds steady, the walls don't shift, the floor stays exactly where you expect it to be. There's a quiet agreement between your senses and your surroundings that says, nothing is moving right now. And yet, as we gently uncovered just a moment ago, that feeling isn't quite telling the whole story. Because even when everything appears calm, even when your body feels completely at rest, there is motion happening beneath that calm. Constant, smooth, uninterrupted motion. So why don't you feel it? The answer begins with something surprisingly simple. Your body doesn't detect speed, it detects change. That distinction might seem small at first, but it explains almost everything about why motion can disappear so completely from your awareness. Think about a moment you've experienced before, sitting in a car, perhaps on a long highway. At first, when the car begins to move, you feel it immediately. The push as it accelerates, the slight shift in your posture, the sensation of movement pressing against you. But after a while, once the speed becomes steady, something interesting happens. The sensation fades. If the road is smooth enough, if the motion is consistent, it can begin to feel almost as if the car has stopped. You might look down at your phone or out the window, and unless something changes, you could forget entirely that you're moving at all. The only time that awareness returns is when something shifts again. A turn, a bump, a sudden brake, a gentle acceleration. It's not the motion itself that you feel, it's the change in motion. Your body is equipped with systems designed to notice acceleration. Inside your inner ear, there are tiny structures filled with fluid that respond when your speed changes or when your direction shifts. They act like sensors, quietly monitoring how your body moves through space. But when everything is moving smoothly, at a constant rate, those sensors have nothing to report. No change, no signal. And without that signal, your brain assumes stillness. This is why you can sit on a plane traveling at hundreds of kilometers per hour and feel completely at rest. The cabin is stable, the motion is constant, and your senses have no reason to raise any alarms. It's also why turbulence feels so noticeable, not because the plane suddenly becomes fast, but because its motion becomes uneven. Your body notices the change. Now, bring that idea back to where you are right now. The Earth's rotation is incredibly smooth. There are no sudden starts or stops, no sharp turns, no jolts that would alert your inner ear. It has been spinning at a steady rate for billions of years. From your perspective, it might as well be standing still. The same is true for the Earth's orbit around the Sun. It's a continuous, graceful motion guided by gravity, with no abrupt shifts in speed or direction. And because everything around you is moving with that same motion, there is no contrast, no reference point that would allow you to notice it. This brings us to another important idea. Motion is always relative. To understand whether something is moving, you need something else to compare it to. If you're sitting in a train at a station and another train begins to move beside you, there's often a brief, slightly confusing moment where you're not quite sure which train is actually moving. For a second or two, it can feel like you're drifting backward, even if you're completely still. That's because your brain is trying to interpret motion based on relative cues. It looks at what's changing in your environment and uses that to decide whether you're moving or something else is. Without a clear reference point, that interpretation can become uncertain. Now imagine removing all external references entirely. No nearby objects, no shifting scenery. Just you, moving smoothly through space, surrounded by things that are moving exactly as you are. In that situation, motion becomes invisible. There's nothing to compare against, nothing to measure change. And so, your brain defaults to stillness. This is the situation you're in right now. Everything you can see, everything you can touch, everything around you shares the same motion as you. The ground beneath you, the air around you, the buildings, the trees, even the clouds above. They're all part of the same system, and because of that, there is no relative motion between you and your immediate surroundings. From your perspective, nothing is moving. But step outside that shared system, even just in your imagination, and the picture begins to change. Imagine you could pause everything around you except yourself. The Earth stops spinning. The air becomes still, the entire environment freezes in place. But you continue moving at the speed you were already traveling. Suddenly, the illusion would vanish. You would feel the wind rushing past, the ground slipping beneath you, the overwhelming sensation of motion that was always there but hidden. Of course, that scenario isn't something we can experience directly, but it helps illustrate how much of what we perceive depends on comparison. Without contrast, motion fades into the background. And there's another layer to this as well. Your brain is constantly filtering information. At any given moment, there is far more sensory input than you could ever consciously process. Sounds, textures, temperatures, subtle shifts in balance. Countless details flowing in all at once. If your brain tried to pay attention to all of it equally, it would quickly become overwhelmed. So it prioritizes. It focuses on what changes, what stands out, what might require a response. Constant, unchanging signals are gradually tuned out. You've probably noticed this with sounds. A fan humming in the background, the quiet buzz of a refrigerator, distant traffic outside a window. At first, you might hear it clearly, but after a while it fades, not because the sound has stopped, but because your brain has decided it's not important. Motion works in a similar way. The constant movement of the Earth, the steady orbit around the Sun, the larger motions we'll soon explore, all of these are consistent, predictable, and unchanging from your immediate perspective, so your brain lets them go. It treats them as background. And what remains is the feeling of stillness. There's something quietly fascinating about that, isn't there? The idea that stillness isn't necessarily the absence of motion, but the absence of noticeable change. That your sense of being at rest is not a direct reflection of reality, but a carefully constructed experience, shaped by how your body and brain interpret the world. It also explains why certain types of motion feel so different from others. Sudden acceleration feels intense. A quick turn can make you dizzy. A drop in an elevator can create that brief, weightless sensation in your stomach. Those are all changes. Your body is responding exactly as it's designed to. But steady motion, no matter how fast, slips past unnoticed. You could be moving at extraordinary speeds, and as long as that motion remains constant, it becomes almost indistinguishable from being completely still. This is why astronauts in orbit often describe a sense of floating calm, despite travelling at tens of thousands of kilometers per hour around the Earth. Their motion is smooth, continuous, and shared with everything around them. From inside their spacecraft, it feels like quiet stillness. And in a way, that's exactly what you're experiencing right now. A kind of grounded version of the same phenomenon. You're part of a system that is moving together smoothly and continuously, without interruption. There are no sudden shifts to draw your attention, no contrasting motion to reveal what's happening, so your senses remain quiet, and your mind interprets that quiet as stillness, and even as you remain right where you are, comfortable, settled, and at rest, the journey continues quietly beneath you, carrying you forward without ever asking you to notice. Let's bring our attention a little closer again. Not out to the vastness of space just yet, not to distant stars or galaxies, but to something much more familiar, the ground beneath you. It feels steady, doesn't it? Reliable, solid, exactly where it should be. If you were to place your hand on a table or press your feet gently into the floor, there's a quiet sense of certainty there. Nothing is shifting, nothing is sliding away, nothing suggests that you're moving at all. And yet, quietly, continuously, and without pause, the entire surface beneath you is turning. The Earth is spinning. Not slowly, not gently in the way it feels, but at a speed that would seem almost unbelievable if you were to experience it directly. Let's take a moment to unpack that. The Earth completes one full rotation approximately every 24 hours. That's the familiar cycle we experience as day and night. The sun appears to rise, travel across the sky, and set again, marking the passage of time in a way that feels natural and predictable. But that daily rhythm hides something much more dynamic. The Earth isn't just turning in place like a stationary object gently rotating on a table. It's enormous, and because of that size, the outer edges of that rotation move incredibly fast. Imagine drawing a circle. The larger the circle, the longer the path around its edge. If you spin a small object, the distance covered in one rotation is small. But if you spin something the size of a planet, the distance around it becomes vast. At the equator, where that distance is greatest, the circumference of the Earth is about 40,000 kilometers. Now, if that entire distance is covered in 24 hours, the speed works out to roughly 1,670 kilometers per hour. That's faster than most commercial airplanes. It means that if you were standing at the equator, you would be travelling eastward at that speed simply by standing still. No effort required, no sensation, just carried along by the rotation of the planet. Even if you're not at the equator, even if you're somewhere farther north or south, you're still part of that rotation. The speed changes slightly depending on your latitude, becoming slower as you move toward the poles, but the motion never stops. Wherever you are right now, you are turning with the Earth. And it's been happening your entire life. From the very first moment you experienced anything at all, you were already in motion, already part of this continuous spin. There's something quietly reassuring about that, isn't there? The idea that beneath everything you do, beneath every thought, every step, every pause, there is this steady, dependable movement carrying you along. But it also raises an interesting question. If the Earth is spinning that fast, why doesn't it feel like it? Why aren't we aware of that motion? The answer, as we began to explore earlier, comes back to smoothness and consistency. The Earth doesn't suddenly start spinning each morning and stop at night. It doesn't speed up or slow down in any noticeable way. Its rotation is incredibly stable. Because of that, there's no acceleration for your body to detect. Your inner ear, the part of your body responsible for sensing motion and balance, is tuned to notice changes. It responds when you turn your head, when you accelerate, when your direction shifts. But constant motion, no matter how fast, doesn't trigger that response. So as the Earth turns, your body simply moves along with it, quietly, effortlessly, without any signal that something is happening. There's also another important detail. The air around you is moving too. The entire atmosphere is carried along by the Earth's rotation. The winds we experience, the gentle breezes or stronger gusts, are layered on top of that motion, but the baseline movement of the air matches the rotation of the planet. This means there's no constant rush of wind sweeping past you at 1,670 kilometers per hour. If there were, it would be impossible to ignore. Instead, everything around you shares the same motion. The ground, the air, the buildings, the trees, the oceans, all of it turning together as a single system. From your perspective, nothing is moving. But if you could step outside that system, even just for a moment, the picture would change completely. Imagine hovering in space, looking down at the Earth. From that vantage point, the rotation becomes obvious. You would see the continents slowly shifting, the oceans turning, the line between day and night moving steadily across the surface. What feels still from here would look undeniably dynamic from there. This difference in perspective is at the heart of why motion can feel so elusive. Inside the system, everything appears calm. Outside the system, the motion becomes clear. There's also something interesting about how this rotation shapes our experience of time. Day and night, one of the most fundamental rhythms of life, is a direct result of the Earth's spin. As the planet turns, different parts of its surface face toward or away from the sun, creating the cycle of light and darkness that we live by. Morning arrives not because the sun moves upward, but because your part of the Earth has rotated into its light. Evening comes not because the sun sinks, but because your location has turned away from it. It's a subtle shift in perspective, but it changes how you think about what's happening. You're not watching the sun move across the sky. You're being carried into and out of its light. And that movement is happening continuously, whether you're aware of it or not. Take a moment to imagine that more vividly. Right now, wherever you are, you're slowly turning toward or away from the sun, depending on the time of day. If it's evening, You're gradually rotating out of the sunlight, moving into the darker side of the planet. If it's morning, you're being carried back into the light, and if it's somewhere in between, that transition is still happening, just more gradually. It's a quiet, constant journey that gives structure to your day without ever announcing itself. There's another small detail worth noticing. Because the Earth is spinning, different parts of the planet are moving in slightly different directions at any given moment. At the equator, the motion is purely eastward, but as you move toward the poles, the path becomes more curved, following smaller circles around the Earth's axis. Yet despite these differences, everything remains coordinated. The entire planet turns together, maintaining its shape, its structure, its balance. It's a kind of large-scale harmony, a motion so well integrated that it becomes invisible from within. And perhaps that's one of the most interesting parts of all this. The fastest movements you experience every day are not the ones you notice. They're the ones that remain constant, the ones that never interrupt you, the ones that simply carry you along moment after moment without asking for your attention. As you sit or lie there now, you are completing part of a rotation that began long before you started listening and will continue long after. In the time it takes to drift through these thoughts, the Earth will have turned just a little more, moving you along its surface without any effort on your part. It's happening right now, quietly, smoothly, without any sensation at all. There's a quiet moment you might recognize, sitting in a train, perhaps, as it begins to glide forward so smoothly that for a second or two, you're not entirely sure whether you're moving or the world outside is. The platform drifts past, slowly at first, and your brain hesitates, trying to decide what exactly is happening. Then the motion becomes clear, but only because something changed. Without that change, without that brief shift from stillness into movement, you might never notice it at all. And that, in a way, is exactly what's happening with the Earth beneath you. Because while we have already uncovered just how fast the planet is spinning, the more interesting question is not the speed itself, but the silence of it. The complete absence of sensation. The fact that something so enormous and so dynamic can feel completely still. To understand that, it helps to imagine a slightly different scenario. Picture yourself standing on a vast, perfectly smooth surface that stretches in every direction. There are no landmarks, no trees, no buildings, no mountains, nothing to give you a sense of position. Just an endless, uniform plain. Now imagine that this entire surface begins to move, not suddenly, not with a jolt, but gradually, gently, until it reaches a steady, constant speed. At first, you might notice something, a faint shift in balance, a subtle awareness that something has changed. But once that motion settles, once it becomes smooth and unchanging, the sensation fades. After a while, it would feel exactly like standing still. Because from your perspective, nothing is changing anymore. The ground beneath you isn't moving relative to you, it's carrying you along. And since everything you can see and touch is part of that same surface, there's no reference point to reveal the motion. That imagined surface is, in a sense, what the Earth is doing. You're not standing on something separate from the motion. You're part of it. You're riding the planet. And not in the dramatic sense. Not like holding on to something that's spinning wildly, but in the most seamless way possible. You and the Earth are moving together, locked into the same motion, sharing the same speed, the same direction, the same path. There's no sliding, no resistance, no sense of being left behind or pushed forward. Just quiet, continuous movement. Another way to think about it is to consider how motion feels when it's uneven. When a car accelerates, you feel pressed back into your seat. When it brakes, your body shifts forward. When it turns sharply, you feel pulled sideways. These sensations come from differences. Your body wants to keep moving the way it was, and when something changes that motion, you feel it as a force. But if the car moves at a constant speed in a straight line, something very different happens. Those forces disappear, There's no push, no pull, no sideways drift. Everything inside the car, including you, is moving together at the same steady rate. From the inside, it feels like rest. The Earth's rotation works in a similar way, but on a much larger scale and with even greater smoothness. There are no sudden changes in speed, no sharp turns, no interruptions, just a continuous, stable motion that has been ongoing for billions of years. Your body has never known anything different. From the moment you were born, you were already moving with the Earth. Your senses developed within that motion. Your brain learned to interpret the world assuming that motion as a constant background. So it doesn't register as something unusual. It registers as normal. There's also the matter of gravity, quietly holding everything in place. The Earth's gravity pulls you toward its center, anchoring you to the surface. It keeps your feet on the ground, your body aligned with the planet, and everything around you in its proper place. Without gravity, the experience of the Earth's rotation would feel very different. You might drift, float, or notice the motion more directly. But with gravity acting constantly, it ensures that you remain firmly connected to the rotating surface. You move with it, not across it. And that distinction matters. If you were sliding across the surface at high speed, you would feel the friction, the wind, the resistance. But because you are carried along, because your motion matches the Earth's exactly, there is no relative movement between you and the ground. No friction, no wind, no signal for your senses to detect. Everything simply aligns. There's a small detail here that often goes unnoticed. Even the air you breathe is part of this motion. The atmosphere rotates with the Earth. It isn't left behind as the planet spins beneath it. Instead, it moves along, held in place by gravity and the same forces that govern the rest of the system. This is why you don't experience a constant, overwhelming wind rushing past you from west to east. The air shares your motion. You and the atmosphere are travelling together, and because of that, the world feels calm. There are winds, of course, but those are local movements, differences within the larger system. They're layered on top of the Earth's rotation, not a result of it. The baseline motion remains hidden. Now consider what would happen if something interrupted that smoothness. If the Earth suddenly sped up, even slightly, you would feel it immediately. Your body would respond to the change, your balance would shift, and the sensation would be unmistakable. The same would happen if it slowed down or changed direction. But because none of those things occur in any noticeable way, the motion remains invisible. It's not that the Earth isn't moving fast enough to be felt, it's that it's moving too consistently. There's a certain elegance to that idea. The faster something moves, the more dramatic we expect it to feel. But in reality, it's the irregularities, the changes, the interruptions that create sensation. Smoothness, even at extreme speeds, can feel like stillness. You might think of it like floating in a calm river. If the water is rushing past rocks and creating turbulence, you'll feel every shift and swirl. But if the current is smooth and even, carrying you gently along, the motion becomes almost imperceptible. You're still moving, perhaps quite quickly, but without disturbance. It feels like rest. That's what it means to ride the planet. You're part of a motion so smooth, so stable, and so all-encompassing that it becomes indistinguishable from stillness. And because everything around you shares that motion, there's no contrast to reveal it, no external reference, no signal to your senses, just the quiet assumption that nothing is happening. But something is happening, constantly. You're being carried along by the Earth's rotation, even now, as you sit or lie in place. Every second that passes, you're moving with the planet, tracing a circular path through space, completing a rotation that began long before this moment and will continue long after. And yet, from where you are, it feels like you haven't moved at all. That contrast between what is happening and what is felt is one of the most subtle illusions we live with every day. It doesn't disturb us. It doesn't demand attention. It simply exists in the background, quietly shaping our experience without ever stepping into the foreground. Long before you notice the passing of a single day, before any sense of morning or evening settled into something familiar, another journey was already underway. It doesn't begin when you wake up, and it doesn't pause when you sleep. It doesn't reset at midnight or slow down on quiet afternoons. It continues, steadily and without interruption, carrying you along a path so large that it's almost impossible to picture all at once. While the earth turns beneath your feet, it is also travelling. Not in a small circle, not in a gentle drift, but in a wide, sweeping path around the sun, and you are travelling with it. If the daily spin of the earth is like standing on a slowly turning platform, then this next motion is more like being carried along a vast, invisible track that loops through space over the course of a year. We mark that journey with seasons, with changing light, with the slow shift from colder days to warmer ones and back again. But behind those familiar changes lies something much more dynamic. The Earth is orbiting the Sun at an average speed of about 107,000 kilometers per hour. That's nearly 30 kilometers every second, which means that in the time it takes you to take a single breath, you've already travelled dozens of kilometers through space without feeling any of it. There's something quietly astonishing about that, because unlike the Earth's rotation, which at least has a visible effect in the form of day and night, this motion is even more hidden. You don't see the path you're tracing. You don't feel the speed. You don't notice the constant forward motion. And yet it's happening, continuously, every moment of your life. To make sense of this, it helps to imagine the scale involved. The distance between the Earth and the Sun is about 150 million kilometers. That distance defines the size of the orbit, a vast, nearly circular path that the Earth follows year after year. If you could step far enough away to see it from the outside, you would watch the Earth tracing that path, moving steadily along its orbit, never stopping, never hesitating. But from where you are inside that motion, it feels like stillness. And once again, the reason comes back to the same idea: smoothness, consistency, and the absence of noticeable change. The Earth doesn't suddenly leap forward in its orbit. It doesn't jerk or wobble in a way that your body could detect. Instead, it follows a path guided by gravity, continuously falling toward the Sun while also moving sideways fast enough to miss it. That combination creates a stable orbit, a kind of endless fall that never quite reaches its destination. It's a delicate balance, but one that has been maintained for billions of years, and because that motion is so steady, your body has no reason to notice it. There's no acceleration that stands out, no sudden shift in direction, just a continuous curve through space. You might wonder, though, if the Earth is constantly changing direction as it orbits, why don't we feel that? After all, moving in a circle means you're always turning, even if only slightly. And it's true. The Earth is constantly changing direction as it travels around the Sun. But the scale of that curve is so enormous, and the change so gradual, that it becomes imperceptible. It's a bit like walking along a very large circle. If the circle is small, you notice the turning immediately. Your path curves, your body adjusts, and the motion is obvious. But if the circle is so large that the curve stretches over thousands of kilometers, each step feels almost perfectly straight. The turning is still there, but it's too gentle to detect in the moment. That's the kind of curve the Earth is following. Fast, gradual, and incredibly smooth. And because of that, the motion remains hidden. There's also another layer to this. Everything around you is sharing that same orbit. The ground beneath you, the air around you, the oceans, the atmosphere extending far above, all of it is moving together along the same path. So once again, there's no relative motion to reveal what's happening, no wind rushing past from the direction of travel, no sense of being carried forward, just the quiet illusion of standing still. If you could somehow step outside of that shared motion, even just for a moment, the experience would be completely different. You would see the Earth moving along its orbit, the Sun at the centre, and the vast distance being covered every second. You would watch entire days pass as the planet continues its journey, tracing that enormous path through space. But from here, inside the system, it feels like nothing is moving at all. And yet, this motion shapes so much of what we experience. The seasons, for example, are not caused by the Earth being closer to or farther from the Sun in any simple way. They are the result of the Earth's tilt combined with its orbit. As the Earth travels around the Sun, different parts of the planet receive varying amounts of sunlight at different times of the year. That's what creates the gradual shift from winter to spring to summer and back again. So even though you don't feel the motion itself, you experience its effects. The changing length of days, the angle of sunlight, the slow transformation of the environment around you. All of these are tied to that steady journey through space. It's a reminder that motion doesn't have to be felt to be real. Sometimes it reveals itself indirectly through the patterns it creates. There's something else worth noticing here. This journey never pauses, not for a moment. There's no point during the year when the Earth stops and rests before continuing. It's always moving, always progressing along its path. Even as you sleep, even as you sit quietly, even in the stillest moments of your day, you are being carried along that orbit. If you think back to a moment from earlier today or even yesterday, the distance you've travelled since then becomes almost difficult to grasp. Hundreds of thousands, even millions of kilometres, depending on how far back you go. And yet, from your perspective, you've simply gone about your day, moved from one room to another, sat down, stood up, maybe taken a walk. The larger motion remains hidden behind the smaller ones you can feel. There's a quiet contrast there, between the movements you notice and the ones you don't, between the steps you take and the journey you're already on. It also raises an interesting thought. If someone were to ask you how far you've travelled today, you might think in terms of meters or kilometres, a short walk, a drive, perhaps a longer trip. But if you include the Earth's orbit, the answer becomes something entirely different. You've travelled tens of thousands of kilometres through space, without trying, without noticing, without any sensation at all. It's a different way of thinking about movement, not as something you initiate, but as something you're part of, a journey that continues whether you pay attention to it or not. As you remain where you are, comfortable and at rest, the Earth continues along its path, carrying you with it. The Sun remains at the centre of that motion, not pulling you directly, but shaping the path you follow. And all of it happens with such smoothness that it feels like stillness. It might feel at this point like we've already uncovered something quite surprising. You're spinning with the Earth, you're orbiting the Sun. That alone is enough to turn the idea of sitting still into something a little uncertain. But there's another layer quietly waiting underneath all of this, one that shifts the picture again in a way that's even harder to imagine at first, because the Sun itself isn't standing still either. Everything we've talked about so far has been centered around the Sun as if it were fixed in place, like the hub of a wheel with the planets moving neatly around it. And for many everyday purposes, that's a perfectly useful way to think about it. But in reality, the Sun is also moving. And when it moves, it carries the entire solar system along with it. Which means that as the Earth orbits the Sun, and as you sit quietly on the Earth, you're also following a much larger path through space, a path that doesn't loop back on itself in a simple circle, but stretches forward continuously like a long, spiralling journey. To begin to picture this, it helps to step a little further back. Our solar system is part of a galaxy, the Milky Way, a vast collection of hundreds of billions of stars all bound together by gravity. The Sun is just one of those stars, and like the others, it is orbiting the centre of the galaxy. That motion is not slow. In fact, the Sun, along with all the planets, asteroids and everything else gravitationally tied to it, is travelling at roughly 828,000 kilometres per hour around the centre of the Milky Way. That's about 230 kilometres every second. Which means that while you've been listening to this, while your thoughts have been gently following along, You've already travelled thousands of kilometres through the galaxy, and just like before, you don't feel any of it. Because once again, everything around you is moving with you. The Earth is still spinning. The Earth is still orbiting the Sun. But now, the entire system is also moving together, following the Sun as it traces a path around the galactic centre. You might imagine it like this. If the Earth's orbit around the Sun is a circle, and the Sun were perfectly still, then that circle would remain neatly closed, repeating year after year. But because the Sun is moving forward through space, the Earth's path becomes something more like a spiral, not looping back to the exact same place, but advancing continuously. Each year you return to roughly the same position relative to the Sun, but not the same position in the galaxy. You are always somewhere new. There's something quietly fascinating about that. The idea that even though our calendars repeat, even though seasons come and go in familiar cycles, the larger journey never circles back. You are never exactly where you were before. Not in space, not in the galaxy, not in the wider universe. Every moment carries you forward. Now, just as before, the reason this motion feels invisible comes down to the same principles: smoothness, consistency, shared movement. The Sun doesn't suddenly lurch forward or slow down in a way that your body could detect. Its motion through the galaxy is steady and continuous, and because the entire solar system is gravitationally bound to it, everything moves together. There's no wind rushing past you at hundreds of thousands of kilometers per hour. No sensation of being pulled along. No signal to your senses that something extraordinary is happening. From where you are, everything still feels calm, still grounded, still at rest. But if you could somehow step outside of this system far enough away to watch it from a distance, the picture would look very different. You would see the Sun moving through the galaxy, not alone, but with a kind of trailing structure behind it. The planets orbiting as they go, the Earth tracing its spiral path, the entire system advancing through space like a quiet, continuous journey, and you, somewhere on that small blue planet moving along with it. There's also a gentle shift in perspective that happens here. Up until now, it might have felt like you were moving around something, around the Earth's axis, around the Sun, but now you're also moving with something, following the Sun, carried along by it. It's no longer just circular motion, it's directional, forward, ongoing, without pause. This raises an interesting thought. If everything is moving together, how would you ever know? The answer, once again, is that you wouldn't. Not directly. Your senses are designed to detect local changes, not vast, uniform motions shared across enormous distances. So the larger the system you're part of, and the more smoothly it moves, the more invisible that motion becomes. It fades into the background, becomes the default, and your experience of stillness remains intact. There's a quiet elegance to that. The faster and more expansive the motion, the more likely it is to go unnoticed. What feels stable and unmoving is often part of something far more dynamic. As you sit or lie where you are now, perhaps feeling completely still, you are part of a layered motion that extends far beyond anything you can sense directly. You are spinning with the Earth, you are orbiting the Sun, and you are following the Sun through the galaxy. All at once, all continuously, all without interruption. If you could zoom out far enough, past the Sun, past the outer planets, past the distant edges of the solar system where sunlight becomes faint and thin, the view would begin to change in a way that's difficult to picture all at once. The familiar structure of orbits and planets would shrink into something much smaller, almost delicate, as the wider shape of our galaxy comes into focus. A vast, slowly rotating system of stars, gas and dust, stretching across unimaginable distances. This is the Milky Way, and somewhere within it, not at the centre, not at the edge, but in a quiet region about halfway out, the Sun is moving, which means once again that you are moving too, not just around the Sun, not just spinning with the Earth, but travelling through the galaxy itself, following a path that takes hundreds of millions of years to complete. To begin to grasp this, it helps to imagine scale in a slightly different way. The Earth's orbit around the Sun feels large when you think about it in kilometres, but it repeats every year. It's something you can relate to through seasons and time. The Sun's journey around the galaxy is something else entirely. One full orbit around the centre of the Milky Way takes roughly 225 to 250 million years. That's sometimes called a galactic year, which means that since the time dinosaurs walked the Earth, the Sun has completed only about one full trip around the galaxy. That's how large this motion is. And yet, even at that immense scale, the speed involved is enormous. As mentioned earlier, the Sun, along with the entire solar system, is travelling at around 828,000 kilometres per hour as it orbits the galactic centre. That's fast enough to circle the Earth many times in a single hour. But once again, none of that speed is something you feel, because just like before, everything around you is part of the same motion. The Earth, the Moon, the planets, even the distant objects bound to our solar system, all of it is moving together as one system, carried along by the Sun's path. There's no separation between you and that motion, no relative difference that would make it noticeable, just a continuous shared journey. Now, what exactly are we orbiting? At the centre of the Milky Way lies a region known as Sagittarius A star, a supermassive black hole with a mass millions of times greater than the Sun. It's not pulling everything inward like a vacuum in the way it's sometimes imagined, but it does play a central role in the gravitational structure of the galaxy. The stars, including our Sun, move under the combined gravitational influence of everything in the galaxy, with that central region acting as a kind of anchor point. So the path the Sun follows is not a perfect circle, but a complex orbit shaped by the mass of billions of stars and the distribution of matter throughout the galaxy. And within that motion, the Earth continues its smaller cycles, spinning daily, orbiting yearly, all nested inside this much larger journey. It's like being part of multiple overlapping paths at once, each with its own scale and rhythm. There's something quietly humbling about that. The idea that your everyday experience, the simple feeling of sitting still, exists within layers of motion that stretch across such vast distances and timescales. And yet, despite all of that, your immediate experience remains calm, grounded, unchanging. Because from your perspective, nothing is shifting. Your room stays in place. The objects around you don't drift away. The ground beneath you feels solid and still. That's because all of this motion is shared. It's not something happening to you from the outside. It's something you are part of. To make this a little easier to picture, imagine being inside a large, smoothly moving train. Not one with windows showing the outside world rushing past, but one where everything inside moves together perfectly. You, the seats, the air, everything. If the train moves at a constant speed, and there are no vibrations, no sounds of motion, no external reference points, it would feel exactly like standing still. Now imagine that train is not just moving along a straight track, but following a vast, gentle curve that takes millions of years to complete, and everything inside it is unaware of that curve because it's so gradual. That's closer to what's happening with the Sun's orbit around the galaxy. You are inside that motion, carried along without any sensation of movement. And because the scale is so large, the curvature of the path is almost impossible to notice from within. There's another small detail that adds to this picture. The Sun doesn't move alone. It travels with a kind of local group of stars, sometimes referred to as a stellar neighbourhood. These stars share similar motions through the galaxy, creating a kind of collective flow. So even on the scale of nearby stars, there is a sense of shared movement, a kind of gentle drift through the galaxy. And again, because everything in your immediate environment is part of that same flow, it reinforces the illusion of stillness. Nothing appears to move relative to you. So your brain continues to interpret the world as stable, as unmoving. But step far enough back, and the entire scene transforms. You would see the galaxy rotating, stars tracing their paths around the centre, vast clouds of gas shifting slowly over time, and within that you would see the sun carrying its planets along a long continuous orbit. And somewhere on one of those planets you would be moving along with it, quietly, effortlessly, without ever feeling the speed. There's also something interesting about how time fits into this. The motions we've been talking about so far unfold over very different timescales. The Earth's rotation takes a day. Its orbit around the Sun takes a year. But this galactic orbit takes hundreds of millions of years, which means that from a human perspective, it doesn't feel like motion at all. It feels like permanence. The stars in the sky appear fixed, forming patterns that seem unchanging over a lifetime. But those patterns are slowly shifting. The stars are moving. It's just happening so gradually that it becomes invisible to us. Our sense of time is too short to notice it directly, and so, once again, motion hides itself. Not because it isn't there, but because it unfolds on a scale that our senses aren't designed to track. As you remain where you are now, perhaps feeling completely at rest, you are part of this immense ongoing journey. You are orbiting the centre of the galaxy. You are travelling at hundreds of thousands of kilometres per hour, and yet from your perspective, nothing is moving. That contrast between the vastness of what's happening and the quiet simplicity of how it feels is something we carry with us all the time. We live inside these motions, we're shaped by them, but we rarely notice them. Beyond the gentle rotation of stars around the galactic centre, there's another layer waiting quietly in the background, one that's even harder to picture because it has no obvious reference point at all. Up until now, it might have been comforting to imagine that while everything inside the galaxy is moving, the galaxy itself is, in some sense, steady, a kind of vast stage on which all these motions unfold. But that isn't quite how it works. The Milky Way is moving too, not in a tight orbit like the Earth around the Sun, and not in a simple, clearly defined path, but drifting, interacting, and flowing through an even larger structure that stretches across the universe, a structure sometimes described as the cosmic web. This web is made up of immense filaments of galaxies, clusters, and vast empty regions called voids. If you could see it from far enough away, it wouldn't look like a neat pattern or a tidy system. It would look more like a loose network, threads of matter stretching across enormous distances, with galaxies gathered along those threads like tiny points of light. And within that network, our galaxy is not fixed. It is moving. To understand this motion, it helps to step even further back in scale. Galaxies are not isolated. They exist in groups and clusters, bound together by gravity. The Milky Way, for example, is part of a small collection known as the Local Group, which includes the nearby Andromeda Galaxy and dozens of smaller galaxies. These galaxies are not simply sitting beside one another. They are interacting, slowly moving, influenced by each other's gravity, tracing paths that will eventually bring some of them closer together. In fact, the Milky Way and Andromeda are on a long, gradual course toward one another, expected to merge billions of years from now. But even that interaction is only part of the story. The entire local group itself is moving. It is being pulled by the gravitational influence of larger structures, drifting toward a region of space known as the Great Attractor, a massive concentration of galaxies and matter that exerts a subtle but persistent pull. So now, layered on top of everything else, there is yet another motion. The Earth spins. The Earth orbits the Sun. The Sun orbits the centre of the galaxy moves within the local group, and the local group drifts through the cosmic web. All of these motions are happening at once, all of them are continuous, and still from where you are everything feels calm, still, unmoving. There's something quietly remarkable about that. The idea that you can be part of so many overlapping journeys, each one unfolding on a different scale, and yet experience none of them directly. If you could step outside of all of this, far enough to see the motion clearly, the picture would be almost impossible to hold in your mind all at once. You would see galaxies drifting along filaments, clusters pulling on one another, vast regions of space expanding and stretching. You would see the Milky Way moving, not as a static shape, but as part of a larger flow. And within it, you would see the sun carrying its planets, and within that the Earth turning, and within that you. It becomes a kind of nested motion, each layer contained within the next, each one adding to the overall journey. And yet, at your scale, none of that motion feels urgent, none of it feels fast. Because once again, everything around you shares that same movement. There's no contrast, no sudden change, no signal for your senses to detect, so your experience remains grounded, stable, still. There's also an important detail here that changes how we think about motion on this scale. Unlike the neat, repeating orbits we see closer to home, the movement of galaxies through the cosmic web is not a simple loop. It doesn't bring you back to where you started. It's more like a drift, a gradual, ongoing shift through space, influenced by gravity, shaped by the distribution of matter, and guided by the expansion of the universe itself. So while the Earth completes a rotation each day and an orbit each year, and the Sun completes a galactic orbit over hundreds of millions of years, the larger motion of the galaxy is not cyclical in the same way. It's directional, evolving, always moving forward into new regions of space. There's a subtle difference there, one that becomes more noticeable the further out you look. The closer you are to a system, the more structured and predictable the motion appears. The farther out you go, the more complex and open-ended it becomes, and somewhere within all of that, you remain part of the motion. Not as an observer standing outside it, but as a participant carried along by it. There's also something quietly humbling about how little of this we can perceive directly. The stars in the night sky appear fixed, forming patterns that seem unchanged across generations. But in reality, those stars are moving. The galaxy is shifting. The entire structure is evolving over time. It's just happening so slowly and on such a large scale that it becomes invisible to us. Our senses are not designed to track motion across millions or billions of years. They are tuned to the present, to immediate changes, to what matters right now. And so, the larger motions fade into the background. They become part of the stage, rather than something we notice. But even if you can't feel it, even if you can't see it directly, it's still happening. Right now, you're drifting through the galaxy, and the galaxy is drifting through the universe, and all of it is happening with such smoothness, such consistency, that it feels like nothing is moving at all. There's a quiet contrast here, between the simplicity of your immediate experience and the complexity of what's actually happening, between the feeling of stillness and the reality of motion. Take a moment and notice the quiet around you. Not in a dramatic way, not searching for anything unusual, just the ordinary sense of stillness that comes when nothing seems to be happening. The room holds its shape, objects remain where they are, and your body feels settled into place. It's a very convincing feeling, the sense that things are stable, unmoving, exactly as they should be. And yet, by now, there's a small shift in perspective beginning to settle in. Because once you start looking a little closer, that stillness begins to soften. Not disappear, not vanish entirely, but become something a little more layered. Everything is moving, even when it looks completely still. That idea might seem obvious after everything we've explored so far, but there's something deeper to it than just large-scale motion. It's not only the Earth spinning or orbiting, not only the sun moving through the galaxy, not only the galaxy drifting through the cosmic web. It goes further than that, much closer, much smaller. Because motion doesn't only exist on the scale of planets and stars, it exists in everything, right down to the smallest levels you can imagine. Consider something simple, A glass of water sitting on a table, from where you are it looks perfectly still. The surface is calm, the shape doesn't change, nothing about it suggests movement. But inside that glass, the water molecules are in constant motion. They are vibrating, shifting, colliding with one another, moving in ways that never fully stop. Even at room temperature, that motion is continuous. It doesn't pause when you look away. It doesn't settle into complete stillness. It only appears that way from the outside. The same is true for the air around you. It might feel calm, especially if there's no breeze, but the molecules in that air are moving in all directions, bouncing, colliding, exchanging energy. Every breath you take is part of that motion. And then there's your own body. Your heart beats, your lungs expand and contract. Your cells carry out countless processes every second. Blood flows, signals travel through your nervous system, muscles adjust in tiny ways to maintain balance. Even when you're completely still, your body's active, moving, constantly. There's something quietly reassuring about that. The idea that stillness doesn't mean inactivity, that beneath the calm surface there is always motion, always activity, always something unfolding. But there's another layer to this idea, one that connects everything we've talked about so far, because all of these small emotions exist within the larger ones. The movement of molecules happens while the Earth spins. The flow of your breath happens while the planet orbits the sun. Your heartbeat continues while the solar system travels through the galaxy. All of these motions are nested inside one another. None of them interrupt the others, they simply coexist. And because of that, the overall experience remains calm, stable, still. It's a bit like listening to music with multiple layers, a steady rhythm, a melody, perhaps a background harmony. Each part is moving in its own way, but together they create something that feels smooth and unified. You don't focus on every individual note, you experience the whole, and in that experience the complexity becomes simplicity. That's what's happening with motion. There are countless layers, from the smallest to the largest, all unfolding at once, but your perception blends them into a single, coherent experience. And that experience feels like stillness. There's also an interesting detail about how your brain handles this. It is constantly predicting what will happen next. Based on past experience, it builds expectations about the world. Objects stay where they are. The ground remains beneath your feet. The room doesn't suddenly shift. These expectations allow you to navigate the world efficiently, without needing to analyze every moment from scratch. But they also reinforce the illusion of stillness, because as long as things behave predictably, your brain doesn't question it. It assumes stability, even when that stability is part of a much larger motion. There's a quiet contrast here, between what is happening and what is noticed, between the constant activity of the world and the calm interpretation your mind creates. And neither of those is wrong. The motion is real. The stillness is also real, in the sense that it reflects your experience. They exist together. One doesn't cancel out the other. You're moving through space at incredible speeds, and at the same time, you're resting comfortably, feeling completely still. Both are true. There's something gently grounding about that idea. It means that motion doesn't have to feel chaotic. It doesn't have to be overwhelming. It can be smooth, continuous, almost invisible. Something you're part of without needing to think about it. And perhaps that's why it's so easy to overlook. Because nothing about it demands your attention. There's no sudden shift, no dramatic change, no interruption. Just a quiet, ongoing movement that carries everything along. Even the things we consider fixed are part of that. The ground beneath you is moving. The objects around you are moving. The entire environment is part of a system in motion. But because it all moves together, it feels like stability. It feels like home. There's also a subtle shift in how you might begin to think about stillness itself. Instead of being the absence of motion, it becomes something else. A kind of balance. A state where motion is present but not noticeable. where everything moves together in a way that cancels out the sensation of movement. That kind of stillness is not empty. It's full of activity, just hidden from view. And as you remain where you are now, perhaps feeling that quiet sense of rest, you are part of all of it. The small motions, the large ones, the ones you can feel, the ones you can't, all happening at once, all unfolding without interruption. Imagine asking a very simple question. How fast am I moving right now? It sounds straightforward. You might expect a single number, something clear, definite, easy to hold on to. But as soon as you begin to look a little closer, that question starts to shift, because the answer depends on something you might not immediately think about. Compared to what? Speed, as it turns out, is not an absolute thing. It doesn't exist on its own, floating independently in the universe. It always describes motion relative to something else. Without that reference point, the idea of speed begins to lose its meaning. You can see this in everyday situations. If you're sitting in a parked car, your speed relative to the road is 0. But if another car passes by, your speed relative to that car is suddenly something different. If you're walking forward inside a moving train, your speed relative to the train might be slow, but relative to the ground outside, it's faster. And if someone were watching from far above, your motion would combine both of those movements at once. None of those perspectives are wrong. They're simply different ways of describing the same situation. And that's the key idea. Motion is always relative. Now bring that idea back to where you are right now. If you measure your speed relative to the chair you're sitting on, or the floor beneath you, you're not moving at all. From that perspective, your speed is 0. But if you measure your speed relative to the center of the Earth, you're rotating along with the planet. Relative to the Sun, you're orbiting at about 107,000 kilometers per hour. Relative to the center of the Milky Way, you're moving even faster, and relative to the larger structures of the universe, that motion becomes part of something even more complex. So which one is correct? All of them. That's what makes this idea so interesting. There isn't a single, universal answer to how fast you're moving. There are many answers, each depending on the frame of reference you choose. This concept is known as a reference frame. It's simply the point of view from which you measure motion. And once you start thinking in terms of reference frames, the idea of stillness begins to change. Because being still doesn't mean not moving at all. It means not moving relative to your chosen reference. Right now, you feel still because you are at rest relative to your surroundings. The room, the floor, the objects around you, they all share your motion. So from that perspective, nothing is changing. But shift the reference frame, and the picture changes immediately. From the perspective of the sun, you are moving very quickly. From the perspective of the galaxy, faster still. From the perspective of something even farther away, your motion becomes part of an even larger flow, and yet your experience doesn't change. You still feel calm, still grounded, still at rest. There's something quietly fascinating about that. The idea that motion is not something fixed, but something that depends on how you choose to look at it. It also explains why certain situations can feel confusing at first. Think again about that moment in a train when another train begins to move beside you. For a brief second, it can feel like you're the one moving, even if you're not. Your brain is trying to determine which reference frame to use. Is the platform the reference? The other train? Your own train? Until it settles on one, the sensation can feel uncertain. But once it does, everything becomes clear again. You either feel like you're moving, or you feel like you're still, even though the underlying motion hasn't changed. There's a deeper layer to this as well. In everyday life, we tend to choose reference frames that are convenient. The ground beneath us, the room we're in, the planet we live on. These are stable, familiar, and easy to relate to, so we describe motion relative to them. But those choices are not fundamental. They're just practical. If you were living on another planet, you would naturally use that planet as your reference. If you were floating in space, far from any large object, your sense of motion would become much less intuitive. Without a clear reference, it becomes difficult to define what moving even means. And that's where things begin to connect to deeper ideas in physics, because when scientists study motion, especially at very large or very small scales, they often have to choose carefully which reference frame to use. Different frames can reveal different aspects of the same phenomenon, and sometimes switching perspectives can make something complicated become simple, or something simple become complicated. There's also a subtle shift in how we think about speed itself. We often imagine speed as something absolute, a number that exists independently, but in reality, speed is always tied to comparison. It's always about how one thing moves relative to another. Without that comparison, the number has no meaning. You could say you're moving at 100,000 kilometers per hour, but unless you specify relative to what, that number doesn't fully describe anything. It's incomplete. And yet, in everyday life, we rarely notice this. Because our reference frame is so consistent. We live on the Earth. We measure speed relative to the ground. We experience motion in a way that feels stable and intuitive, so the relativity of motion stays hidden, much like the motion itself. There's something quietly elegant about that. The idea that the universe doesn't provide a single fixed answer to how fast you're moving. Instead, it offers many perspectives, each valid in its own way. And your experience depends on which one you choose, even if you don't realize you're choosing at all. You can hold on to that thought. You are still, from one perspective, you're moving incredibly fast from another. Both are true at the same time, there's no contradiction. Just different ways of looking at the same reality. Numbers can be a little deceptive. You hear something like 1,000 kilometers per hour or 100,000, and for a moment it sounds impressive, maybe even overwhelming. But then the number fades into abstraction, becoming just a figure without much meaning attached to it. That's because speed, on its own, is difficult to feel. It needs context, something to compare against. So instead of thinking about these speeds as isolated numbers, it helps to place them side by side, gently, almost like laying them out on a table and noticing how they relate to one another. We'll start small. A typical walking pace is around 5 kilometers per hour. It's the kind of movement you're familiar with. You feel each step, the shifting of your weight, the rhythm of your body moving forward. If you double that speed, perhaps jogging lightly, it becomes more noticeable. Your breathing changes, your muscles engage more actively, the sensation of motion becomes clearer. A car moving through a city might travel at 50 kilometers per hour. On a highway, perhaps 100 or 120. At that point, the motion becomes something you can feel if it changes suddenly, but when it's steady, it begins to fade into the background again. Then there are airplanes. A commercial jet typically cruises at around 800 to 900 kilometers per hour. From the outside, that seems incredibly fast. But from inside the cabin, once the plane reaches its cruising speed, it feels calm, almost still. You can sit, read, rest, and aside from the subtle hum of the engines, there's very little to remind you of the speed. That's the first hint that speed alone doesn't define your experience. Now, place that next to the Earth's rotation. At the equator, around 1,670 kilometers per hour. Faster than a plane, and yet completely unnoticed. Then step up to the Earth's orbit around the Sun, about 107,000 kilometers per hour. At this point, the numbers begin to stretch beyond everyday intuition. It's more than 100 times faster than a jet, and still, there's no sensation. No wind rushing past you, no sense of acceleration, just quiet stillness. Then we move to the motion of the Sun through the Milky Way, roughly 828,000 kilometers per hour. Now we're approaching speeds that feel almost abstract, hundreds of kilometers every second. In the time it takes to blink, you've already traveled farther than most journeys you would take in a day. And yet nothing about your immediate experience changes. The room remains still, your body remains at rest, The sensation of motion remains absent. If we continue this gentle comparison, we can go even further. Galaxies themselves move within clusters, and clusters move within the larger structure of the universe. Some of these motions reach into the millions of kilometers per hour, but even those are not the upper limit. There is a speed in the universe that stands apart from all others, the speed of light. Light travels at approximately 300,000 kilometers per second, not per hour, per second. It's so fast that light from the sun reaches the Earth in about 8 minutes. The light you see from distant stars has been travelling for years, sometimes thousands or millions of years, just to reach your eyes. Compared to that, even the motion of the Earth around the sun begins to feel slow. Even the movement of the galaxy seems measured. The speed of light becomes a kind of boundary, a limit that nothing with mass can reach or exceed. And that gives us a gentle sense of scale. From walking to driving to flying to planetary motion to galactic motion and finally to the speed of light. Each step upward increases the speed dramatically, and yet your experience remains largely the same. Stillness, calm, a sense of being at rest. There's something quietly interesting about that contrast. The fastest speeds you're part of are not the ones you feel. They're the ones that are most consistent, the ones that don't change, the ones that carry everything together. If you were suddenly accelerated to one of these speeds, if there were a sharp change, your body would notice immediately. But because these motions are steady, because they've always been there, they become invisible. There's also a subtle shift in how you might begin to think about speed itself. It's not just about how fast something is moving, it's about how that motion fits into a larger context. A car feels fast compared to walking. A plane feels fast compared to a car. But compared to the Earth's orbit, both are almost still. And compared to the speed of light, even planetary motion feels slow. Each layer changes the meaning of the numbers. Each comparison reshapes your sense of scale. And somewhere within all of that, your own experience remains grounded. You sit, you rest, you breathe. And despite being part of these enormous speeds, you feel completely still. There's a quiet kind of comfort in that. The idea that motion doesn't have to be overwhelming, that even at incredible speeds things can feel calm, stable and steady. As you remain where you are part of all of these layers at once. The smaller speeds you can feel, the larger ones you can't. All overlapping, all continuous, all unfolding without interruption. At some point, a quiet question begins to form. All of these speeds, the Earth spinning, the planet orbiting the sun moving through the Milky Way, they sound precise, almost too precise. Numbers like 1,670 kilometers per hour, 107,000 kilometers per hour, hundreds of thousands more on larger scales, and yet no one has ever stood outside the Earth and watched it spin in real time with their own eyes. No one has stepped outside the solar system to measure its path with a stopwatch. So how do we actually know? How do we measure something we can't directly step outside of? The answer, gently, is that we don't measure motion in the way we might measure the length of a table or the height of a wall. We measure it indirectly, we observe patterns, we track changes, and we build a picture from those observations piece by piece until the motion reveals itself. It's a bit like watching shadows move across a room. You might not see the sun moving directly, but you notice how the light shifts, how the shadows stretch and shorten, how the angle changes over time. From those changes, you can begin to understand what's happening. Motion leaves clues, and science is, in many ways, the careful reading of those clues. Let's begin with something familiar, the rotation of the Earth. Long before satellites or modern instruments, people noticed that the sun appeared to rise and set in a regular pattern. Day followed night, night followed day, and the cycle repeated with remarkable consistency. At first, it seemed natural to think that the sun was moving around the Earth, but over time, observations became more detailed. The positions of stars shifted in predictable ways. the length of shadows changed depending on the time of day and the time of year. By carefully tracking these patterns, it became clear that it was the Earth that was turning. Not because someone felt it spinning, but because the sky behaved in a way that made sense if the Earth rotated. And once you know the size of the Earth and how long it takes to complete one rotation, calculating the speed becomes a matter of simple geometry. You take the circumference, divide it by the time, and the number appears. Not guessed, not imagined, but derived from observation. The same approach extends outward. The Earth's orbit around the Sun was understood by watching the positions of planets and stars over long periods of time. Astronomers noticed that certain patterns repeated annually. The Sun's position against the background stars shifted gradually, returning to the same point after about a year. Planets traced complex paths across the sky, sometimes moving forward, sometimes appearing to loop backward. At first, these motions seemed complicated, but when viewed from the perspective of a moving Earth orbiting the Sun, they began to make sense. Once again, the motion revealed itself through patterns, and once the shape and size of that orbit were understood, the speed could be calculated. Distance over time, a quiet, consistent method that works even when the motion itself cannot be felt. As our tools improved, so did our ability to measure these motions more precisely. Telescopes allowed astronomers to observe distant objects with greater clarity. Clocks became more accurate, allowing for better timing of events, and eventually new techniques began to emerge. One of the most important is something called the Doppler effect. You may have noticed it before, even if you didn't know the name. When a car passes by with its engine running, the sound changes pitch. As it approaches, the sound is slightly higher. As it moves away, the sound drops. That change happens because the motion of the car affects the way sound waves reach your ears. Light behaves in a similar way. When an object in space moves toward us, the light it emits shifts slightly towards shorter wavelengths, a phenomenon known as blue shift. When it moves away, the light shifts toward longer wavelengths, known as red shift. By measuring these tiny shifts in light, scientists can determine how fast an object is moving relative to us, not by touching it, not by chasing it, but by reading the subtle changes in the light it sends. This method has been used to measure the motion of stars, galaxies, and even the expansion of the universe itself. It's a quiet kind of measurement, careful, indirect, but incredibly powerful. There's another approach as well. Tracking positions over time. If you observe a star or a planet or any object in the sky and record its position very precisely, you can compare that position over days, months, or years. Even tiny shifts become noticeable when measured carefully. From those shifts, you can calculate motion. It's a bit like watching a distant boat on the horizon. At first, it might seem still, but if you keep your eye on it long enough, you begin to notice that it has moved, slowly, gradually, but unmistakably. With precise instruments, that same idea can be applied to objects far beyond our immediate reach. And then there are spacecraft. Human-made objects sent into space, carrying instruments that can measure position, velocity, and distance with extraordinary accuracy. These spacecraft allow us to test our understanding directly, to see how objects move under the influence of gravity, to confirm predictions, to refine measurements. They act as small, precise markers within the larger system, helping us map the motion of everything around them. There's something quietly elegant about all of this. The fact that we can understand such vast motions without ever leaving the surface of our planet. That by observing light, timing events and tracking positions, we can build a picture of how everything moves. It's not immediate, it's not obvious, but it is consistent, and consistency is what allows these measurements to become reliable. There's also a deeper idea here. We don't need to feel motion to know it exists. We don't need to step outside a system to understand it. We can observe from within, carefully, patiently, and still uncover the patterns that reveal what's happening. It's a bit like understanding the flow of a river without ever leaving the water. You notice the direction of currents, the way objects drift, the subtle changes over time, and from those observations you begin to understand the larger motion. The speeds we've been talking about are not guesses, they are the result of centuries of careful observation, refined again and again as our tools improved. And yet, despite all that precision, your experience remains the same. Calm, stable, still. There's a quiet balance there, between what we know and what we feel, between the vast motion we can measure and the stillness we experience. At some point, the question quietly circles back again. Not how fast you're moving, but something even more fundamental. Compared to what? Because once you begin to accept that motion is always relative, that there is no single, absolute answer, another thought naturally follows. Is there any true reference point at all? Something completely still. Something you could measure everything else against. A kind of universal background that doesn't move. It's an appealing idea. A fixed stage beneath everything else. A place where motion could finally be measured in a definitive way. But as it turns out, the universe doesn't quite offer that. There is no single, perfect point of rest. No absolute stillness that everything agrees on. Instead, there are many reference frames, each useful in its own way, each telling part of the story. And understanding that begins to change how we think about motion entirely. Let's return for a moment to something simple. Sitting in a room. From your perspective, you are at rest. The chair, the floor, the walls, everything around you shares your motion, so nothing appears to change. That's your local reference frame. It's the one your senses rely on, the one your brain uses to interpret the world. Now shift slightly outward. Instead of measuring your motion relative to the room, measure it relative to the center of the Earth. Suddenly you are moving, carried along by the planet's rotation. Shift again. Now measure your motion relative to the Sun. You're travelling at over 100,000 kilometers per hour as the Earth orbits. Shift once more. Relative to the center of the Milky Way, your speed increases again, following the Sun's path through the galaxy. Each step outward changes the answer. Each reference frame reveals a different layer of motion, and none of them is more correct than the others. They are simply different perspectives. But what if we go even further? What if we try to find a reference frame that isn't tied to a planet or a star or even a galaxy? Something more universal, something that belongs to the universe itself. There is in fact something close to that. A kind of faint background that fills all of space. It's called the cosmic microwave background. This is the leftover light from the early universe, a faint glow that remains from a time when the universe was much hotter and denser. It's everywhere. No matter which direction you look, it surrounds you, and because of that, it provides a kind of reference. Not perfect, not absolute, but very useful. When scientists measure the motion of our galaxy relative to this background, they can detect a slight difference in the temperature of that radiation depending on the direction. In one direction, it appears slightly warmer, in the opposite direction slightly cooler. This difference comes from motion. It's similar in principle to the Doppler effect we mentioned earlier, but applied to the entire sky. By measuring that shift, scientists can determine how fast we are moving relative to this cosmic background, and the number is quite large. The Milky Way, along with everything in it, including you, is moving at about 2.1 million kilometers per hour relative to the cosmic microwave background. That's nearly 600 kilometers per second. It's one of the largest speeds we can assign in a meaningful way. And yet, even here, something interesting happens. This reference frame, as useful as it is still not absolute. It's simply another perspective, a very broad one, tied to the large-scale structure of the universe, but not a fixed, unmoving stage. Because the universe itself is expanding. Space is stretching. Distances between galaxies are increasing over time. So even this background, even this seemingly universal frame, exists within a changing system. There is no final, unchanging point to measure everything against. And that brings us back to the original idea. Motion is always relative, not just in everyday situations, but at every scale. There is no ultimate answer to how fast you're moving. There are only answers within specific frames of reference, and each one tells you something different. There's something quietly freeing about that. The idea that motion isn't tied to a single, rigid definition, that it depends on perspective, that the question itself invites multiple answers rather than one fixed number. It also changes how we think about stillness. If there is no absolute frame of rest, then being still becomes a local idea. You're still relative to your surroundings, relative to the room, the ground, the immediate environment, and that's enough for your experience. Your body doesn't need a universal reference frame, it only needs a stable one. But from a wider perspective, that stillness is always part of a larger motion, one that depends on how far outward you choose to look. There's a gentle shift here, from thinking of motion as something fixed and measurable in a single way, to thinking of it as something layered, contextual and dependent on perspective. And as you remain where you are now, you can hold both ideas at once. You are at rest, and you are moving. You're still within your local frame, and you are travelling at extraordinary speeds within larger ones. Both are true. Neither cancels the other. They simply describe different ways of seeing the same moment. There is a point where speed stops being just another number and becomes something different. Up until now, we've been gently building a sense of scale, from walking to flying to planetary motion to the movement of entire galaxies. Each step has stretched that scale a little further. The numbers grew larger, the distances wider, the speeds more difficult to picture. But even with all of that, there is still a boundary, a limit that nothing we've talked about can cross. And that limit is the speed of light. Light travels at approximately 300,000 kilometers per second, not per hour, not per minute. Every single second, light covers a distance that would take a commercial airplane weeks to travel. If you could move at that speed, you could circle the Earth more than 7 times in just 1 second. It's a number that almost refuses to settle into intuition. It's simply too fast to compare directly to anything we experience in daily life. But what makes it truly interesting is not just how fast it is, it's the fact that it is the same for everyone. No matter how fast you are moving, no matter where you are, no matter how you measure it, the speed of light remains constant. That idea at first sounds simple enough, but it leads to something quite profound. Because earlier we explored how motion is always relative, how speed depends on perspective, on reference frames, on what you're comparing against. And in most cases that works perfectly well. But light behaves differently. If you were standing still and measured the speed of light, you would get the same result as someone moving at a significant fraction of that speed. Even if you were moving very quickly, light would still move away from you at 300,000 kilometers per second. It doesn't add or subtract in the way you might expect. It doesn't adjust itself to your motion. It simply stays the same, and because of that, something else has to change instead. That something turns out to be space and time themselves, but we'll ease into that gently in a moment. For now, it's enough to notice that the speed of light acts as a kind of universal limit. Nothing with mass can reach it. No object, no spacecraft, no planet, no star. No matter how much energy you add, no matter how much you try to accelerate, you can get closer and closer to that speed, but you can never quite reach it. It's like approaching a horizon that always remains just out of reach. And this limit shapes everything. It defines how information travels. It determines how quickly cause can lead to effect. It sets the pace at which the universe can communicate with itself. There's also a quiet consequence of this that you may have already noticed. When you look at distant objects, you are not seeing them as they are right now. You're seeing them as they were when the light left them. The sun, for example, is about 8 light minutes away, which means the light you see from it left the sun 8 minutes ago. You're always looking slightly into the past. For nearby objects, that delay is so small that it doesn't matter, but as distances increase, the effect becomes more noticeable. The light from the moon takes just over a second to reach you. From nearby stars, it takes years. from distant galaxies millions or even billions of years. So when you look up at the night sky, you're seeing a layered history of the universe, different objects at different stages in time all arriving at your eyes simultaneously. It's a quiet reminder that speed is not just about motion, it's about connection, about how quickly one part of the universe can influence another, and the speed of light sets that limit. Now, there's another gentle shift that comes from this idea. If nothing can move faster than light, then even the fastest motions we've talked about, the Earth's orbit, the Sun's journey through the galaxy, the motion of galaxies themselves, all of them are still relatively slow compared to this ultimate limit. Even travelling at hundreds of thousands of kilometres per hour, or even millions, you're still far below the speed of light. And that gives a kind of perspective, a sense of where all these motions sit within the larger structure of the universe. There's also something quietly reassuring about the consistency of it. No matter where you are, no matter how you're moving, the speed of light remains the same. It doesn't depend on your perspective in the way other speeds do. It provides a kind of anchor, not a fixed point in space, but a fixed relationship between space and time. And because of that, it becomes a reference in a different sense. Not something you measure motion against directly, but something that defines how motion behaves. As you sit or lie where you are now, surrounded by that familiar sense of stillness, this limit exists quietly in the background. Every signal, every beam of light, every interaction that depends on the transfer of information is bound by it. And even though you are moving through space at remarkable speeds, those speeds are still far below this ultimate boundary. There's a gentle contrast there, between the vast motions you're part of and the even greater scale set by the speed of light. Something rather unexpected begins to happen when motion becomes extreme. Up to this point, speed has felt like a matter of perspective. You can be moving quickly relative to one thing and slowly relative to another. You can be part of several motions at once and still feel completely at rest. The numbers grow larger, the scales widen, but your experience remains calm and unchanged. Then, quietly, the rules begin to shift. Not in a dramatic way, not something you would notice in everyday life, but in a way that becomes undeniable when speeds approach a certain limit. Because motion doesn't just describe how things move through space. At high enough speeds, it begins to affect time itself. That idea might sound abstract at first, but it's actually one of the most carefully tested and well understood parts of modern physics. And like many things we've explored, it doesn't announce itself loudly. It reveals itself gently through careful observation, through subtle differences, through changes that are too small to feel but too consistent to ignore. To begin to understand this, it helps to return to something familiar. Imagine two identical clocks. Not ordinary clocks, but perfectly precise ones, ticking at exactly the same rate. Place one of them on a table in front of you. Take the other and send it on a journey. At first, nothing seems unusual. Both clocks tick forward, second by second, minute by minute in perfect agreement. But now imagine that the travelling clock begins to move very fast. Not the speed of a car or a plane, but much faster. Fast enough that the effects we're about to describe become noticeable. When that clock returns and you place it beside the one that stayed behind, something surprising happens. They no longer agree. The travelling clock has ticked fewer seconds. It has experienced less time, not because it malfunctioned, not because something went wrong, but because time itself passed differently for it. This effect is known as time dilation, and it comes from the same set of ideas that gave us the constant speed of a light. The key insight is this: if the speed of the light must remain the same for all observers, no matter how they are moving, then something else has to adjust to make that possible, and what adjusts is space and time. They are not fixed, they are flexible, they respond to motion. At everyday speeds, this effect is so small that it's impossible to notice without extremely precise instruments. But it's there, always, even now. As you sit or lie where you are, time is passing for you at a slightly different rate than it would for someone moving at a different speed. The difference is tiny, so small that it doesn't affect your experience in any meaningful way, but it exists, and it becomes more pronounced as speed increases. To get a gentle sense of this, imagine once again that travelling clock. If it were placed on a fast-moving airplane and flown around the Earth, when it returned, it would be just a tiny fraction of a second behind the clock that stayed on the ground. This has been tested, measured, confirmed. The difference is incredibly small, but it matches exactly what the theory predicts. The faster the motion, the greater the effect. Now imagine increasing that speed even further, closer and closer to the speed of light. As that happens, time for the moving clock slows down more and more relative to the stationary one. From the perspective of someone watching from the outside, the moving clock appears to tick more slowly. But from the perspective of the clock itself, everything feels normal. This is an important detail. Time doesn't feel like it's slowing down for the traveller. Their thoughts, their movements, everything proceeds as usual. It's only when you compare the two perspectives that the difference becomes clear. There's something quietly fascinating about that. The idea that time is not the same for everyone, that it depends on how you move, that two observers can experience different amounts of time between the same events. It challenges the intuitive sense that time is universal, flowing at the same rate everywhere. But once you accept it, it begins to fit naturally with everything else we've explored. Motion is relative, speed depends on perspective, and now time does too. There's a well-known thought experiment that illustrates this idea in a more vivid way. It's often called the twin scenario. Imagine two identical twins. One stays on Earth, the other travels into space at a very high speed, close to the speed of light, and then returns. When they reunite, the travelling twin is younger. Not by a tiny fraction of a second, but potentially by years, depending on how fast and how long the journey was. This isn't a trick. It's not an illusion. It's a real consequence of how time behaves at high speeds. The travelling twin experienced less time. Their path through space involved a different relationship with time than the one who stayed behind. And again, from the traveller's perspective, nothing felt unusual. Their clock ticked normally. Their experience of time felt the same. It's only when the two are compared that the difference appears. There's a gentle shift in how you might begin to think about time here. Instead of being something fixed and universal, it becomes something more personal, something that depends on your motion, your path through space, the way you move relative to everything else. And this brings us back to where you are right now. You are moving, not at speeds anywhere near the speed of light, but still moving through space as part of the Earth, the solar system, and the galaxy. Because of that motion, time for you is slightly different than it would be if you were moving at a different speed. The difference is incredibly small, so small that it has no noticeable effect on your daily life. But it is real, and it has to be accounted for in certain situations. For example, satellites orbiting the Earth move at high speeds compared to the surface. Because of that, time for those satellites passes slightly differently. Their onboard clocks tick at a different rate. To keep systems like GPS accurate, these differences must be corrected. Without those corrections, the errors would quickly add up. Your location could drift by kilometers in a matter of minutes. So even though the effect is subtle, it has practical consequences. It's part of how the world works. There's also another side to this idea. Speed is not the only thing that affects time. Gravity does as well. Stronger gravitational fields can slow down time, but we'll ease into that more fully in the next part. For now, it's enough to notice that time is not as fixed as it once seemed. It's connected to motion. It changes depending on how you move, and yet, within your own experience, it remains steady, consistent, reliable. You don't feel time slowing down or speeding up. Your moments pass as they always have, second by second, breath by breath. There's a quiet contrast there between the flexibility of time on a larger scale and the steadiness of your experience, between the measurable differences and the feeling of continuity. And as you remain where you are, perhaps feeling that familiar sense of stillness, all of this is unfolding quietly in the background. You are moving through space, and because of that motion, time itself is subtly shaped by the path you're on, not in a way that disrupts your experience, but in a way that connects you to something much larger, a universe where space and time are not separate, where motion weaves them together. Morning arrives, and without thinking too much about it, you begin your day. You wake up, perhaps glance at the time, maybe stretch a little, and step into a routine that feels familiar. The hours pass in a way that seems steady and reliable. Breakfast, work, conversations, small pauses in between. Everything unfolds in a sequence that feels consistent. Time moves forward, not too fast, not too slow, just as it always has. And yet, quietly, beneath that steady rhythm, something more subtle is happening. Because the time you are experiencing, the seconds ticking by, the minutes passing unnoticed, are not quite the same as they would be if you were somewhere else, moving differently, or sitting in a different gravitational field. The difference is small, so small that you will never feel it directly. But it's there, and it's part of your everyday life. To understand this gently, it helps to return to something we explored just a moment ago. Time is not completely fixed. It changes slightly depending on motion and gravity. At very high speeds, time slows down relative to slower moving observers. In stronger gravitational fields, time also slows down compared to regions where gravity is weaker. These effects are not dramatic in everyday situations, but they are real. And because they are real, they show up in places you might not expect. Let's start with something familiar: satellites. There are many of them orbiting the Earth right now, quietly circling the planet, providing signals that help with communication, navigation, and timing. One of the most well-known systems that depends on them is GPS, the system that allows your phone to determine your position, guide you through streets, and tell you where you are with surprising accuracy. At first glance, it might seem simple. Satellites send signals, your phone receives them, the position is calculated, but underneath that simplicity is something much more delicate. Each satellite carries extremely precise clocks. These clocks measure time down to incredibly small fractions of a second. Because to determine your position, the system needs to know exactly how long it takes for a signal to travel from the satellite to your device. Even tiny errors in timing would lead to large errors in position. Now, here's where relativity quietly enters the picture. Those satellites are moving very fast relative to the surface of the Earth, and they are also farther away from the Earth's centre, where gravity is slightly weaker. Both of these factors affect how time passes for them. Because of their speed, time on the satellite slows down slightly. Because of the weaker gravity, time speeds up slightly. These two effects don't cancel each other out perfectly. The result is that the clocks on the satellites tick at a different rate than clocks on the ground. If this difference were ignored, the system would quickly become inaccurate. Positions would drift, navigation would fail, so engineers account for it. They adjust the clocks to ensure that everything stays synchronized. It's a quiet correction, invisible to you, but essential. And it's happening constantly. Every time you use your phone to check directions or find a location. There's something quietly remarkable about that. The idea that the way you navigate through a city depends, in part, on the way time itself behaves at different speeds and in different gravitational fields. That relativity, something that might seem abstract or distant, is actually part of your daily life, not in a way you notice, but in a way that quietly supports the systems you rely on. There are other examples as well. Even the clocks used in scientific experiments must account for these effects. When measurements need to be extremely precise, even small differences in altitude can matter. A clock placed slightly higher above the Earth's surface will experience time just a little differently than one placed lower down. The difference is tiny, but measurable and consistent. It's a reminder that time is not perfectly uniform across space. It varies gently depending on where you are and how you're moving. Now, bring that idea back to your own experience. As you sit or lie where you are, time feels steady. Each second follows the last in a predictable way. There's no sense of it speeding up or slowing down. Your internal rhythm remains unchanged. And yet, if you were to compare your clock to one moving at a different speed, or one positioned differently in a gravitational field, there would be a difference. Small, but real. You are, in a sense, living on a moving clock. A clock that is shaped by the motion of the Earth, by its orbit around the Sun, by its journey through the galaxy, and by the gravitational environment you are in. All of these factors influence how time passes for you. Not enough to disrupt your day, not enough to change how you experience each moment, but enough to be measurable, enough to matter in the right context. There's a gentle shift in perspective here. Time is no longer something completely separate from motion. It's connected, intertwined. The way you move through space affects how you move through time, and because you are always moving, always part of these larger motions, time is always quietly adapting. There's also something comforting about how stable your experience remains despite all of this. Even though time can vary, even though it's influenced by speed and gravity, your local experience stays consistent. Your body, your thoughts, your sense of the present moment all move together, so you never feel out of sync. You never notice the difference. Everything you experience is self-consistent. That's what allows life to feel smooth, predictable, grounded. The deeper complexity remains in the background, handled by the laws of physics, quietly ensuring that everything fits together. As you continue through your day, or as you rest and listen now, you are part of this system. You're moving through space. And because of that motion, you're also moving through time in a way that is subtly shaped by it. Not in a way that changes your experience, but in a way that connects you to a larger picture. A picture where time is not fixed, where motion and gravity influence its flow, and where even the simplest moments, the quietest pauses, are part of something much more intricate. Most of what your brain does never asks for your attention. Right now, without you needing to think about it, your breathing is adjusting, your posture is being maintained through tiny corrections, your balance is quietly stabilized, and your senses are filtering an enormous amount of information down to something manageable. All of that is happening automatically, and somewhere within that quiet background work is the reason why you don't notice the motion we've been talking about. Because even though you are moving through space at extraordinary speeds, your brain has decided that this information is not important enough to bring into your awareness. Not because it isn't real, but because it doesn't change. To understand that, it helps to think about how your brain handles information in general. At any given moment, there is far more sensory input than you could ever consciously process. Light entering your eyes, sounds reaching your ears, pressure on your skin, signals from your muscles and joints, temperature changes, internal sensations from your body, all of it arriving at once. If your brain tried to treat all of this information equally, it would quickly become overwhelmed. So instead, it filters, it prioritizes, it looks for patterns, for changes, for anything that might require a response, and it quietly sets aside everything else. This process is sometimes called sensory adaptation. You've experienced it many times. If you walk into a room with a noticeable smell, you might detect it immediately. But after a few minutes, the smell fades, even though the air hasn't changed. If you put on a watch or a ring, you feel it at first. But after a while, the sensation disappears from your awareness. The input is still there. Your brain has simply decided that it's constant, predictable, and not worth focusing on. Motion works in a very similar way. The Earth's rotation is constant. Its orbit is constant. The motion of the solar system and the galaxy is constant. There are no sudden changes, no unpredictable shifts, nothing that requires your attention for survival. So your brain filters it out. It treats it like background noise. and what remains in your awareness is the feeling of stillness. There's also another system at work here, one that's more directly related to motion. Inside your inner ear is a structure called the vestibular system. It's responsible for detecting changes in movement and helping you maintain balance. It responds to acceleration, to changes in speed and direction. When you turn your head, when you move quickly, when you lose balance, this system sends signals to your brain helping you adjust. But when motion is constant, when there is no acceleration, the vestibular system becomes quiet. It has nothing to report. So even though you are moving at high speed as part of the Earth's rotation and orbit, there is no acceleration for this system to detect. From its perspective, everything is stable, and because of that, you feel stable. There's also the matter of prediction. Your brain is not just reacting to the world, it is constantly predicting it. Based on past experience, it builds a model of what should happen next. Objects remain where they are. The ground stays beneath your feet. The environment behaves in a consistent way. When reality matches those predictions, your brain doesn't need to update anything. It doesn't need to draw your attention to it. But when something unexpected happens, a sudden movement, a change in direction, a loss of balance, your brain immediately notices. It updates its model. It brings the information into your awareness. This is why sudden motion feels so noticeable, and constant motion does not. The motion we've been discussing is not just constant. It's something your brain has always experienced. From the moment your sensory systems developed, you were already part of this motion. There was never a time when you were not moving with the Earth, so your brain has no baseline for comparison, no alternative state to contrast it with. For your brain, this motion is not just background, it is the default, and because of that, it becomes invisible. There's something quietly fascinating about that idea. The fact that your experience of reality is shaped not just by what exists, but by what changes, by what stands out, by what requires attention. Everything else fades into the background, no matter how large or significant it might be. Even something as vast as the motion of the Earth through space. There's also a practical side to this. If your brain did notice every layer of motion all the time, it would be overwhelming. Imagine constantly feeling the Earth's rotation, the orbit around the Sun, the motion through the galaxy. Your sense of stability would be disrupted. Your ability to focus on immediate tasks would be reduced. Instead, your brain gives you a stable frame of reference. It anchors your experience to your immediate surroundings. And within that frame, everything feels calm, predictable, still. This stability is not a mistake. It's a feature. It allows you to function, to move, think, and interact with the world without being distracted by the vast motions that are always present. There's also a subtle shift here in how you might think about perception itself. What you experience is not a direct reflection of everything that is happening. It's a carefully filtered version, a version that highlights what matters for your immediate survival and well-being, and quietly sets aside the rest. That doesn't make it less real. It just means it's selective. As you sit or lie where you are now, feeling that sense of stillness, your brain is maintaining that experience for you, filtering out the constant motion, focusing on what changes, keeping your awareness grounded. And yet, beneath that calm surface, all of the motion we've been exploring continues, uninterrupted, unnoticed. You're moving through space. You're part of multiple layers of motion, and your brain is allowing you to experience that as stillness. There's something gently reassuring about that. The idea that even in a universe full of movement, your experience can remain steady. That motion doesn't have to feel chaotic. It can be smooth, consistent, and quiet. A small shift is all it takes to turn something invisible into something impossible to ignore. You can sit in a quiet room for a long time without noticing the weight of the air around you. You can rest your hands on a surface and forget they're even there. You can exist within a steady environment that feels calm, predictable, and still. Then something changes. A door closes, a chair moves, A sudden sound breaks the silence, and instantly your attention moves with it. That difference between what is constant and what changes is where motion becomes meaningful. Because motion, on its own, is not always something you notice, but change always is. Up to this point, we've been gently uncovering layers of motion that surround you at every moment. The Earth spins, the planet orbits the sun moves through the Milky Way, and the galaxy itself drifts through the larger structure of the universe. All of that motion is real. All of it is happening right now, and yet none of it feels like movement, because none of it is changing in a way your senses can detect. This is the key idea. Movement becomes noticeable when it changes, not when it simply exists. To understand this more clearly, it helps to think about how your body responds to motion. When you're sitting still, your body is in a balanced state. Gravity pulls you downward, the surface beneath you supports your weight, and everything feels stable. If nothing changes, that stability continues. But if something shifts, even slightly, your body reacts. If you lean forward, your muscles adjust. If the ground beneath you tilts, your balance shifts. If you accelerate suddenly, your body feels the force. It's not the motion itself that creates the sensation. It's the change in motion. This is why a smooth journey feels calm, while a sudden one feels intense. A train gliding at a constant speed can feel almost motionless, but the moment it accelerates or slows down, you feel it immediately. The same principle applies at every scale. The Earth's rotation is constant, its orbit is constant. The motion of the solar system and the galaxy is constant. There are no sudden shifts, no abrupt changes that would draw your attention. So your brain treats all of it as background, as something that doesn't need to be noticed. There's another way to think about this. Imagine you are watching a perfectly still image. Nothing moves, nothing changes. Your attention begins to drift. Now imagine that a single element in that image starts to move, even slightly. Your attention immediately focuses on it, because change stands out. Change carries information. It signals that something is happening. Motion without change, on the other hand, carries very little information. It doesn't tell your brain anything new, so it fades into the background. This idea extends beyond physical movement. It applies to how you experience time, sound, light, and even thought. A steady sound becomes quiet in your awareness. A constant light becomes invisible. A repeated idea becomes familiar. But the moment something shifts, your attention returns. Change is what your brain is designed to notice, and because of that, change is what gives motion meaning. There's something quietly interesting about that. The idea that motion itself is not what defines your experience. It's the variation within that motion, the differences, the transitions, the moments where something becomes different from what it was before. This also explains why certain experiences feel longer or shorter. When a lot changes, when your environment is new or unpredictable, your brain records more information. Time feels fuller. When everything is repetitive and unchanging, your brain records less. Time feels compressed. Again, it's not the passage of time itself that changes. It's the amount of change within it. Now, bring this back to the motion you're part of right now. The Earth is spinning at a constant rate. The planet is orbiting the sun smoothly. The sun is moving through the galaxy without interruption. All of these motions are steady, unchanging, predictable. So they carry very little information for your brain. They don't signal anything new. They don't require a response. And because of that, they become invisible. They become part of the background. But imagine just for a moment that something about that motion changed. If the Earth suddenly sped up or slowed down even slightly, you would notice immediately. Your body would feel it. Your environment would shift. The sense of stability would break. Motion would become obvious. Not because it suddenly appeared, but because it changed. That's the moment when movement becomes meaningful. There's also a gentle philosophical shift here. It suggests that what we experience as reality is not just a collection of things that exist, but a collection of changes. We notice what evolves, what transforms, what moves relative to what came before. Everything else fades into the background, even if it is vast, even if it is constant, even if it is happening at incredible speeds. As you sit or lie where you are now, that background motion continues, uninterrupted, smooth, constant, and because it doesn't change, it doesn't ask for your attention. It allows you to feel still, grounded, at rest. There's something quietly reassuring about that. The idea that stability doesn't require the absence of motion. It only requires the absence of change. That you can be part of something dynamic and still experience calm. That motion and stillness are not opposites, but different ways of describing the same situation. One from the outside, one from within. It helps to let go, just for a moment, of the idea that motion always involves things travelling through space, because there is another possibility, one that feels a little unusual at first. What if space itself can move? Up to this point, everything we've explored has involved objects moving within space. The Earth spins, the planet orbits the Sun moves through the Milky Way, and the galaxy drifts through the larger structure of the universe. In every case, something travels from one place to another. But on the larger scale, something different begins to happen. The space between galaxies is expanding, not because galaxies are flying outward through space in the usual sense, but because the space itself is stretching. That distinction might seem subtle, but it changes how we think about motion entirely. To get a gentle sense of this, imagine a surface with small dots drawn on it. Now imagine that surface slowly stretching in all directions. As it expands, the dots move farther apart, but they're not actively travelling across the surface. They're simply being carried along as the space between them grows. From the perspective of any one dot, it looks like all the others are moving away. But there's no central point they're moving away from. No single location where the expansion begins. Every point experiences the same effect. This is very similar to what happens in the universe. Galaxies are like those dots. They are not all rushing outward from a single explosion into empty space. Instead, the space between them is increasing, stretching, carrying them apart. This idea comes from observations made over the last century. When astronomers looked at distant galaxies, they noticed something consistent. The light from those galaxies was shifted toward longer wavelengths, a red shift, and the farther away a galaxy was, the greater that shift appeared to be. At first, this might seem like the familiar Doppler effect, an indication that galaxies are moving away from us, but the pattern was too uniform, too consistent. It suggested something larger, not just motion through space, but the expansion of space itself. There's something quietly elegant about that. The idea that the universe is not static, not fixed in size, but evolving, growing, and that this growth is happening everywhere, not just in one region. Now, what does this mean for you? Does it add another layer to the motion you're already part of? The answer is yes, but in a slightly different way than before. When the Earth spins, you move with it. When the Earth orbits the Sun, you travel along that path. When the Sun moves through the galaxy, you follow. Each of those motions carries you directly. The expansion of the universe is different. It doesn't move you through space in the same way. Instead, it changes the scale of space itself. On very large distances, galaxies become farther apart over time. But on smaller scales, like within galaxies, solar systems, or even your immediate surroundings, gravity and other forces hold things together. So the expansion doesn't stretch everything uniformly. It's not pulling apart the Earth, or the solar system, or even the galaxy. Those structures remain bound, stable. But beyond those scales, the expansion becomes noticeable. Galaxies drift farther apart, clusters separate. The overall structure of the universe changes gradually over time. There's something subtle here. The motion we've been discussing so far has involved movement relative to something else, relative to the Earth, relative to the Sun, relative to the galaxy. But the expansion of space introduces a different kind of change. It's not just about relative motion, it's about the underlying structure of space evolving. Distance is increasing not because objects are actively travelling, but because the framework they exist within is stretching. And yet, from your perspective, none of this is noticeable. The room you're in doesn't expand. The distance between you and the objects around you remains constant. Your experience of space feels stable, just like your experience of motion feels still. This brings us back to a familiar idea. Your perception is local. It reflects what's happening in your immediate surroundings. Large-scale changes, especially those that are smooth and gradual, remain hidden. They don't produce the kind of changes your senses are designed to detect. So even though space itself is expanding, even though the universe is evolving on a grand scale, your experience remains calm, unchanging, grounded. There's also a gentle shift in perspective that comes with this. If space itself can change, if distances can grow without objects actively moving through space, then the idea of motion becomes even more layered. It's no longer just about objects travelling. It's about relationships changing, distances evolving, the structure of the universe unfolding over time. And within that unfolding, you remain part of the system, not as an observer standing outside it, but as something embedded within it. Your position, your motion, your experience, all tied to the larger picture. There's something quietly reassuring about how stable your local experience remains despite all of this. Even though the universe is expanding, even though galaxies are drifting apart, your immediate environment stays consistent. The forces that bind it together are strong enough to maintain that stability. So you can rest, you can feel still, even as the larger structure of the universe continues to evolve. As you remain where you are now, perhaps feeling that familiar sense of calm, the expansion continues, unnoticed, unfelt, a slow, steady change in the fabric of space itself. A question like this doesn't rush to give you an answer. It lingers for a moment instead, because the moment you try to answer it directly, it begins to slip slightly out of reach. Are you moving, or is everything else moving around you? At first, it seems like one of those questions that must have a clear answer. One option has to be correct, and the other must be mistaken. Either you are in motion, or the rest of the universe is. But as we've been slowly uncovering, that kind of certainty becomes harder to hold on to the more closely you look. Because motion, as it turns out, is not something that belongs to a single point of view. It depends entirely on perspective, and once you allow that idea to settle, the question itself begins to change. Not in a confusing way, but in a way that softens the need for a single fixed answer. To see why, it helps to begin with something very simple. Imagine sitting in a quiet room. Nothing around you appears to be moving. The walls are still, the floor is steady, the objects around you remain in place. From this perspective, it feels natural to say that you are not moving. Everything feels at rest. Now imagine that someone outside the building is watching you from a distance. From their perspective, the Earth is rotating. So even though you feel still, you are moving relative to them. And if we shift that perspective further outward, to someone observing from the Sun, your motion becomes part of the Earth's orbit. From that point of view, you are travelling at over 100,000 kilometers per hour. And if we step even further outward, to someone observing from a distant region of the Milky Way, your motion becomes part of the Sun's journey through the galaxy. Each perspective changes the answer. From inside the room, you are still. From outside, you are moving. And both descriptions are valid. There's no contradiction there, just different ways of describing the same situation. This is where the question begins to unfold. Because if you say that you are moving, you are choosing a reference frame. You are comparing your position to something else. And if you say that everything else is moving, you are simply choosing a different reference frame. From your perspective, it is entirely reasonable to say that you are at rest and that everything else is moving around you. In fact, for most of human history, that is exactly how people understood the world. It felt natural. The ground beneath you doesn't seem to move. The sky appears to shift. The sun rises and sets. From that viewpoint, it made sense to say that the Earth was still and everything else moved around it. It wasn't a mistaken observation. It was a natural interpretation based on a particular perspective. Only later, with more detailed observations and careful reasoning, did we begin to adopt a different reference frame, one where the Earth moves and the Sun remains at the centre of the solar system. And even that is just another perspective, useful, consistent, and supported by evidence, but still a choice of reference. Because if you were to describe the motion of the solar system from the Earth's point of view, you could still say that the Sun moves across the sky. The equations would be more complicated, but they would still work. There's something quietly interesting about that. The idea that the universe doesn't force a single viewpoint on you. It allows multiple descriptions, each valid within its own frame. What matters is consistency. As long as the description works within its chosen perspective, it can be used to understand what's happening. This leads to a gentle shift in how you think about motion. Instead of asking which object is truly moving, you begin to ask how different objects move relative to each other. The focus moves away from absolute motion and toward relationships. And once you think in those terms, the question becomes less about choosing one answer and more about understanding the connection between perspectives. Are you moving? Yes, relative to many things. Is everything else moving? Also, yes, relative to you. Both statements describe the same reality from different viewpoints. There's a simple way to see this more clearly. Imagine floating in deep space, far from any planet or star. There are no nearby reference points, no ground beneath you, no horizon, just a vast open expanse. In that situation, how would you determine whether you are moving? If you drift slowly, with no acceleration, no change in direction, there would be no sensation, no signal from your body, no visual cue. From your perspective, you could consider yourself at rest, but from another perspective, you might be moving relative to distant stars or galaxies. Without a chosen reference, the concept of motion becomes ambiguous. It depends entirely on what you compare yourself to. This is one of the reasons why the idea of absolute motion doesn't hold up. There is no universal backdrop that defines what is truly at rest. Only relationships. Only comparisons. And that brings us back to your experience right now. You feel still because your reference frame is local. The room, the ground, the immediate environment. Within that frame, nothing is changing. So your brain interprets that as rest. But if you shift the frame outward, the motion becomes clear. You are moving with the Earth, with the Sun, with the galaxy, with the larger structure of the universe, all at once, and yet none of those motions disrupt your sense of stillness. Because stillness, in your experience, is not the absence of motion. It's the absence of change within your chosen frame. There's something quietly reassuring about that. The idea that you don't need a fixed, universal answer to feel grounded. You don't need to know exactly how fast you are moving in every possible sense.
Your experience is stable because your reference frame is stable, and that's enough. There's also a deeper shift that comes with this. It suggests that many questions about the universe are not about finding a single final answer, but about understanding how different perspectives relate to each other. Motion is not something that belongs to one object or another. It's something that exists between them, a relationship, a comparison. And once you see it that way, the question becomes less about choosing between you are moving or everything else is moving. Instead, it becomes about how those two ideas describe the same situation from different points of view. As you remain where you are now, perhaps feeling that familiar sense of calm, you can hold both perspectives at once. You are at rest and you are in motion. You are still within your surroundings, and you are traveling through space, there's no need to choose between them. They are simply two ways of describing the same moment.
What feels stable is not always unmoving. That might sound like a small distinction, but once it settles in, it begins to change how you look at almost everything around you. The floor beneath you feels firm. The chair or bed supports your weight in a way that suggests permanence. The room holds its shape and nothing appears to drift or slide out of place. It all gives the impression of stillness, not just a temporary pause, but something dependable, something that doesn't require questioning. And yet, layer by layer, that impression has already started to soften. Because the stillness you feel is not the absence of motion, it's something else. It's the result of motion that is so smooth, so consistent, and so shared that it becomes invisible. At first, that idea might seem like a simple extension of what we've already explored. The Earth spins, the planet orbits the Sun, the solar system moves through the Milky Way, and the galaxy drifts through the larger structure of the universe. All of that motion happens without disrupting your sense of calm. But there's a deeper layer to it, because the illusion of stillness is not just about large-scale motion. It's about how your mind constructs reality from what it receives. Your experience of the world is not a direct, unfiltered view of everything that exists. It is a carefully shaped interpretation built from signals that your brain considers important. And what your brain considers important is not everything. It's what changes. It's what stands out. It's what might require a response. Everything else fades into the background, even if it is vast, even if it is constant, even if it is happening at incredible speeds. That filtering process is what allows you to feel stable. Without it, your experience would be overwhelming. Imagine for a moment if your brain did not filter out constant motion, if you were aware of every layer at once, the rotation of the Earth beneath you, the orbit around the Sun, the motion through the galaxy, the drift through the cosmic web, all of it present in your awareness simultaneously. It wouldn't feel calm, it wouldn't feel grounding, it would feel chaotic, unstable, difficult to navigate. Instead, your brain simplifies. It anchors your experience to your immediate surroundings. It creates a local sense of rest, and within that frame, everything feels still. There's something quietly elegant about that. The idea that stillness is not something that exists independently, but something that is created. A kind of agreement between your senses and your mind. A stable interpretation of a dynamic reality. It's also worth noticing how consistent this illusion is. It doesn't flicker. It doesn't come and go. It remains steady. That consistency is what makes it feel real. What makes it feel trustworthy. Because your brain is not constantly re-evaluating the entire structure of motion around you. It builds a model of the world and updates it only when necessary. As long as nothing changes in a way that matters locally, that model remains the same, and that model includes stillness. There's also another subtle layer here, your sense of position. Right now, you likely feel like you're in a specific place, a room, a building, a city. Something with boundaries and location. But when you consider all the motion we've explored, that sense of position becomes more fluid. Because while you feel like you're in one place, that place itself is moving, continuously, without pause. So what does it mean to be here? Is it a fixed point, or is it a moving one? The answer once again depends on perspective. From your local frame, you're in a stable location. From a larger frame, that location is part of a continuous journey. And both are true. There's no contradiction, just different layers of description. This is where the illusion of stillness becomes something more than just a quirk of perception. It becomes a necessary feature of how you experience the world. It allows you to function, to move, think, and interact without being distracted by the vast motions that are always present. It gives you a stable reference, a sense of grounding, even though that grounding is part of something much larger. There's also a quiet shift in how you might begin to think about stability itself. Instead of meaning not moving, It begins to mean moving in a way that doesn't disrupt your experience. Smooth, consistent, predictable. That kind of stability is not about stopping motion. It's about maintaining balance within it. And that's exactly what you're experiencing right now. You are balanced within motion, carried along by multiple layers of movement that align in such a way that they feel like stillness. There's something reassuring about that. The idea that motion doesn't have to feel overwhelming. That even in a universe full of movement, your experience can remain calm, centered, at rest. It also suggests something interesting about how we understand reality. What you perceive is not everything that is happening. It's what is relevant, what changes, what your brain chooses to highlight. Everything else becomes the background. Even if that background includes the motion of entire planets and galaxies. As you sit or lie where you are now, that background remains steady. The illusion of stillness holds, not because nothing is moving, but because everything is moving together. And because your brain has decided that this is the version of reality that matters most for you. There's no need to notice the rest, no need to feel the speed, no need to track the vast journey you're part of. You can simply rest and allow that quiet stability to remain, even as the motion continues beneath it, even as the journey carries you forward, even as the larger picture unfolds.
Picture something that never actually happens. Not slowly, not gently, not over time, but instantly. Everything stops. Not the small things first, not just the Earth's rotation or its orbit, but all of it at once. The spin beneath your feet, the movement around the sun, the motion through the Milky Way, even the larger drift through the universe. All of it comes to a stop. It's the kind of idea that feels simple at first, almost like pressing pause on a video. But the moment you sit with it a little longer, it begins to unfold into something far more complicated. Because stopping motion is not the same as removing motion. It's a change, a sudden one. And as we've been gently exploring, it's the change that matters. Right now, everything is moving together, smoothly, consistently. That's why it feels like stillness. But if that motion were suddenly interrupted, the effect would not feel calm or quiet. It would feel immediate, overwhelming, impossible to ignore. To understand why, it helps to return to something familiar. Imagine sitting in a car that is moving at a constant speed. Everything feels steady. Then the driver presses the brakes suddenly. Your body moves forward. Not because you chose to move, but because your motion continues while the car slows down. That difference creates a force you can feel. Now imagine something similar, but on a much larger scale. The Earth is rotating. At the equator, the surface moves at around 1,670 kilometers per hour.
If that rotation were to stop instantly, everything on the surface would still be moving at that speed. The ground would stop. You would not. You would continue moving eastward, no longer carried by the planet but moving relative to it. The air, the oceans, everything not firmly anchored would continue as well. The result would not be a gentle stillness. It would be a sudden, dramatic shift. A release of motion that had been quietly shared by everything. There's something important here. The motion itself is not what creates the sensation, it's the change. As long as everything moves together, you feel nothing. But the moment that shared motion is broken, the difference becomes impossible to ignore. Now extend that idea a little further. The Earth doesn't just spin, it orbits the Sun at about 107,000 kilometers per hour. If that motion were suddenly stopped, the same principle would apply. Everything on Earth, including you, would continue moving at that speed relative to the Sun. The path would no longer be a smooth orbit. It would become a straight line motion, at least initially, as the balance that keeps the Earth in orbit disappears. Gravity would still act, of course, pulling everything inward, but the sudden change would create effects that are difficult to fully imagine. And then there's the motion of the Sun through the galaxy. Hundreds of thousands of kilometers per hour. If that were suddenly halted, the entire solar system would experience a shift relative to the rest of the galaxy. Again, not because motion itself is unusual, but because the change in motion is. Each layer we've explored adds to the complexity. Each one represents a shared movement that feels invisible only because it is consistent. Remove that consistency, and the illusion of stillness disappears. There's also another way to think about this. Motion, as you experience it, is not something you feel directly. You feel forces, pushes, pulls, accelerations. If you are moving at a constant speed, there is no force acting on you in a way that your body can detect. But if that speed changes, even slightly, your body notices. So when we imagine everything suddenly stopping, what we are really imagining is a massive change in velocity, a sudden shift from one state of motion to another, and that shift is what would be felt, not the stopping itself, but the transition. There's a quiet contrast here. Right now, you're moving at extraordinary speeds, but you feel completely still. In this thought experiment, the speeds disappear, but the sensation would become intense, because the change would be immediate. It's a reminder that what you experience is not determined by how fast you're moving, but by how that motion changes. There's also something interesting about how this thought experiment helps clarify the idea of shared motion. The reason you feel still right now is because everything around you shares the same motion. The ground, the air, the objects around you, all moving together. If that shared motion were removed, even partially, the differences would appear, and those differences would create sensation. So in a way, the illusion of stillness depends on everything remaining aligned, moving together, without interruption. There's also a subtle shift in perspective here. When we think about stopping, we often imagine a kind of peaceful stillness, a quiet pause. But in reality, stopping motion, especially at large scales, is not gentle. It involves forces, changes, adjustments. It's not the absence of movement, it's the interruption of it. And interruptions are what your senses are designed to detect. As you sit or lie where you are now, none of this is happening. There is no sudden stop, no abrupt change. The motion continues smoothly. And because of that, your experience remains calm, stable, still. The thought experiment doesn't change what's happening. It only highlights it. It reveals how much of your experience depends on the consistency of motion, on the absence of sudden change. There's something quietly reassuring about that. The idea that the calm you feel is not fragile. It's supported by the stability of the system you're part of. The Earth continues to spin. The planet continues to orbit. The sun continues its journey through the galaxy, all of it unfolding without interruption. And because of that, you can rest. You can feel still, even as the motion continues beneath you. The word here sounds simple. You use it without thinking. It feels immediate, obvious, almost unquestionable. If someone asks where you are, you can answer easily. A room, a building, a street, a city. Something fixed. Something that feels like a place you can point to. And for most purposes, that works perfectly well. But once you begin to look at it through the lens we've been gently building, something about that idea starts to loosen just a little. Because if everything is moving, if every layer we've explored is carrying you along, then what exactly does here mean? It can't be a fixed point in space, not in the way it first appears. Instead, it becomes something more subtle, a kind of moving reference, a location that exists relative to the things around you, rather than as an absolute position in the universe. To begin to see this, it helps to start small again. Right now, here, might mean the place your body is resting, the surface beneath you, the immediate space around you. That's your local reference frame. Within that frame, everything feels stable. The room doesn't drift away. The objects around you remain in place. From this perspective, here feels fixed, but expand that perspective just a little. The building you're in is attached to the Earth, and the Earth is rotating, which means that you're here is slowly turning, carried along by the planet's spin. Expand it further. The Earth is orbiting the Sun.
So your here is not just rotating, but also tracing a path through space at over 100,000 kilometers per hour. Expand it again. The Sun is moving through the Milky Way, so your here is part of that motion too, following a path around the galactic center. And beyond that, the galaxy itself is drifting through the larger structure of the universe. So your here is not just moving, it is part of multiple layers of motion at once. There's something quietly surprising about that. The idea that the place you feel most anchored to is actually part of a continuous journey. That here is not a single point, but a path. A moving position that changes from moment to moment. And yet your experience of it remains stable. Because your sense of location is not based on absolute position. It's based on relationships, where you are relative to the things around you, the room, the ground, the objects nearby. As long as those relationships remain constant, your sense of here remains constant, even if the entire system is moving. There's another way to think about this. Imagine you are on a ship at sea. The ship is moving, the water is moving, the earth beneath it is rotating. But within the ship, you can still say you are here, the room you're in, the place you're sitting. That sense of location doesn't depend on the ship being stationary. It depends on the stability of your immediate surroundings. The same idea applies here. You are on a much larger ship, the Earth.
And that ship is moving through space. But within it, your local environment remains stable, so your sense of here remains intact. There's also something interesting about how this connects to time, because your sense of now works in a similar way. It feels immediate, fixed. But as we've seen, time is also influenced by motion and gravity. It's not completely uniform. It varies slightly depending on where you are and how you're moving. So just as here is not an absolute point in space, now is not an absolute moment in time. Both are local, both depend on perspective, and both feel stable because your experience is anchored to your immediate frame of reference. There's a quiet shift in perspective here. Instead of thinking of yourself as occupying a fixed position in a static universe, you begin to see yourself as part of a moving system. A system where position is always changing, where here is not a point, but a relationship. And yet, despite all of that, your experience remains grounded. You still feel like you are in one place. You still feel like you are here. That's because your brain is not tracking your position relative to the entire universe. It's tracking your position relative to your surroundings, and those surroundings move with you. They share your motion. So from your perspective, nothing changes. There's something quietly comforting about that. The idea that you don't need a fixed position in the universe to feel stable, that your sense of place comes from the relationships around you, not from an absolute location. It means that even in a universe where everything is moving, you can still feel grounded, still, at rest. There's also a deeper implication here. If here is not a fixed point, then the idea of being lost or found in an absolute sense becomes less meaningful. You're always somewhere, always part of a system, always connected to the structure around you. Your position is defined by those connections, not by a single unchanging coordinate. As you sit or lie where you are now, that sense of here remains steady. The room holds its shape. The ground supports you. Everything feels exactly where it should be. And at the same time, that here is moving, carried along by the Earth, by the Sun, by the galaxy, by the larger motion of the universe, all of it happening quietly, without disrupting your experience. There's a gentle balance in that. Between movement and stability, between change and consistency, between the vast journey you're part of and the simple feeling of being right where you are. For a moment, nothing needs to change. You don't need to move or adjust or look for anything new. The place you're in remains steady, familiar and calm. The surface beneath you supports your weight in the same quiet way it has this entire time. The room holds its shape. The air rests around you without any sense of urgency. It feels like stillness, and yet by now, that word has taken on a slightly different meaning, because what feels still is not motionless. It's something much more subtle. It's motion that has become invisible. From where you are, everything appears exactly where it should be. There's no drifting, no sliding, no sense that you're being carried anywhere at all. Your experience remains grounded, stable, and predictable. But beneath that calm surface, the journey continues. Not dramatically, not in a way that demands attention, but quietly, consistently, without interruption. The Earth is turning. The planet is tracing its path around the Sun. The Sun is moving through the Milky Way. And the galaxy itself is part of an even larger motion. All of these layers unfolding at once. All of them carrying you along. There's something gently surprising about holding both of these ideas together, that you are completely at rest and at the same time moving through space at extraordinary speeds. Neither cancels the other. They simply describe the same moment from different perspectives, and your experience, the feeling of being here, remains centered within that.
There's no rush to resolve the contradiction. No need to choose one idea over the other. You can simply allow both to exist. You are still. You are moving. Both are true. There's also something quietly reassuring about how little effort this requires from you. You don't have to maintain the motion. You don't have to think about it. You don't have to do anything at all. The movement happens whether you notice it or not. It carries you forward without asking for your attention. And because it is so smooth, so consistent, so perfectly shared by everything around you, it feels like nothing is happening at all. That's what allows you to rest, to sit or lie here without any sense of motion, to feel grounded even while you are traveling through space. There's a kind of quiet balance in that. The universe is dynamic, full of movement, full of change, and yet your experience of it can be calm, stable, still. Not because the motion stops, but because it doesn't disrupt you. It doesn't pull you out of the present moment. It doesn't ask for anything in return. It simply continues. As you remain where you are now, you are part of that continuity. Every second that passes, you move a little farther along your path. Not in a straight line, not in a simple circle, but in a layered journey shaped by everything we've explored. Spinning, orbiting, drifting, all at once. There's something quietly expansive about that idea.
The sense that even the most ordinary moment is part of something much larger. That simply being here connects you to movements that stretch across vast distances and timescales. And yet, none of that changes the simplicity of this moment. You are here. You are breathing. You are resting. The larger motion doesn't take that away. It exists alongside it. There's also a gentle shift in how you might think about where you are. Here is no longer just a fixed point. It's a moving place. A position that changes from moment to moment, carried along by the Earth and everything beyond it. And yet, it still feels like home. Because your sense of here is not tied to absolute position. It's tied to your surroundings, to the relationships that remain constant, the ground beneath you, the space around you, the quiet stability of your immediate environment. As long as those remain steady, your experience remains steady. Even as everything else moves, there's something comforting in that. The idea that you don't need a fixed universe to feel grounded, that stability can exist within motion, that stillness can be part of movement, and that you can rest within that balance. Right now, as you listen, as your thoughts move gently from one idea to the next, you're already far from where you were just a short time ago. Not in a way you can feel, not in a way that changes your experience, but in a way that is real. You have travelled thousands of kilometres through space since this began, carried along by the Earth's motion, and yet from your perspective you have simply been here, still, present, at rest. There's a quiet kind of wonder in that, the idea that movement doesn't always feel like movement, that the fastest journeys can be the ones you never notice, that even as you remain completely still, you are part of something in motion, and perhaps that's where this gently settles, not in a conclusion, not in a final answer, but in a way of seeing, a way of holding both stillness and motion together, allowing them to coexist. As you remain where you are now, there's nothing you need to do with that idea. You don't need to follow the motion, you don't need to track the speeds, you can simply rest, knowing that the journey continues quietly beneath you, carrying you forward, without effort, without interruption, and without ever taking away the calm of this moment.